I wasn't muted. Sorry about the pop. Okay, so, oh, jeez. Yeah, so, there's audio spiking out. Let's go down a little bit. People made me turn everything up because they said it was too quiet. Hey, what's up, Wayne Johnson? So, how am I peaking in the focus rate? La 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 la. Bop. Yeah, okay, that gets me into yellow. The compressor should take care of the rest. Yeah, I have to be at negative. I was at negative 3 dB, whatever, negative 3 dB, but I'm at negative 8 now, just because the microphone does different stuff sometimes when I plug it in, which is unfortunate. I need to get to the bottom of that. How's it going, Wayne Johnson? Am I now? Do I now sound okay? And my voice is bright enough and loud enough? I need to go back through and edit some of my audio settings, and I think what I'm going to do is update M-Audio, update my plugins, or use the mixer in order to sound okay. It's just those two, you get two people coming in at the same time and having the exact same commentary about my audio, and it's like I put a lot of work into my audio, and then chat gangs up on me about it. But like, that's my EQ setting. I can probably mess with this a little bit more because there's some muddy stuff in this territory that I could probably tune out a little bit on the lav mic. So I'll probably get to the bottom of that at some point. My hair is ridiculous today. I'll get to the bottom of that at some point and do some live, like, not with you guys, but like do some actual audio tuning in order to get things to sound nice again. And it may just be that I need to take my mixer where I want to have microphones going through and just sit down with it and poke it until everything's good. And if I do a software update, I think I get more features too on the Rodecaster. So yeah, that's got to be a thing that I got to look at. But right now I am like in the red. Last time I ever let my audio be in the red is when people were telling me that it sounded terrible. So they're like, it's crackling and awful. Who knows, man. Why does that look out of focus? Weird. All right, so we got the thumbnail, this time with no border, because nobody does borders anymore, apparently. Get that out of there. This is not very chill. This is not a chill. Let's get this out of here. It's too hard. I need chill. Underworld edition. Oh, sounds kind of dark. Oh, is this just one song? How long is this? 42 minutes. All right, that should be fine. Oh boy. Okay. Yeah. So I've got to update stuff. My audio stuff is old. It's from circa 2017, 2018 when I set everything up. Actually, when I got this microphone is when I did the audio stuff, and I don't remember when that was. I don't remember when that was. My buddy sent me this movie quality lav mic, and I plugged it in directly into the system after we built a driver for it, a preamplifier for it, and I went like this, and I heard, and I was like, that's a little too loud. That's a little much. So I eventually got these plugins at the suggestioning of Leb TV Live, and ran with it from there, and I've never updated them since. So what I need to do is sit down with the device that I want to use and get that tuned so that the lav mic sounds pretty similar to how I sound right now. And the main thing about it is I want it to filter out that little bit of noise in the background. Now I could get a VST. That would mean it's tied to the computer always. If I got the VST, there are like neural network noise cancellation type filters. Now the thing is, I kind of want a little bit of noise in here because we do stuff that's noisy. So, RTX sound is not something that really can work for me. Because, yeah. Oops. No, we're not good enough to have success. Get rid of that. Get that success off of the screen. Jeez. Let's see, every single, yeah, all these have a different Streamlabs. I see. That's actually good. And one thing that I probably should look into is redoing a little bit of the visuals here. I can give stuff a slightly more complicated frame, make it look a little bit nicer, have something say thermal cam and like highlight it. For right now, it's very simplistic. I just kind of threw stuff together to get the stream to work. But I could think about designing it a little bit It would, of course, be me doing all of the stuff. I don't hire people to do my visuals or my emotes or anything else. I'm self-sufficient. I'm not great at everything, but I can at least do it. But having like rounded edges on this would be a little better. And maybe something that says like thermal cam. Maybe not. Maybe that's a little too much. Or I could put a little VCR text over top of this thing that just says thermal. Predator vision. People have come in and I love the predator vision on your channel. And it's like, no. Like, predator vision was not quite thermals. I think it was a thermal camera and a bunch of other stuff. They just kind of noised up the images with. Old school thermal camera. Did they like make that look better in 4K? I think they might have. Yeah, we got a bit of a circuit here that we're testing. We're going to put it together on the soldered prototyping board because breadboarding it is kind of a hassle now that I've built the real circuit. And that looks like, the circuit looks like this. I tried to get that in the thumbnail, but it was a little too janky for the thumbnail. We got our microcontroller over there on the left. Wait a minute, what's going on? I'm still in this tool. How do I get to just like the move around tool? Oh, that's right, it's MS Paint. I do this. That's how you move around. Yeah, so we've got a big bank, a 4500 microfarad capacitor bank. That's these three right here. We charge it with 100 volts. Yeah. That's. Do we call that an AVE joke these days? Not really, because he didn't invent it, but he does use it all the time. I haven't listened to his content in a while. Anyway, we have got 80 milliamps, 100. Let me move 100 volts back up here. 100 volts, 80 milliamps, sitting at the top of all of these capacitors. When we activate the NPNs by putting a high signal here, it will allow, well, just one of them, if we activate this one, the isolating one, it will allow current to flow through our current limiting resistor and charge those caps up to 100 volts. And that'll happen in about 4 seconds. So to speed up the process, we have a second NPN transistor that is just simply shorting out this resistor here. So my prediction is we put in an 800 ohm resistor, and let me just fix up my drawing so I don't get confused about anything. So we do 800 ohms. Which is 125 milliamps. I need a fuzzy selector. Boom selector. 125 milliamps, which brings us to 4 seconds of charging time, but we bypass it and we short out the current limiting resistor, and that gives us super speedy charging time, right? We don't need any of this stuff in there. I didn't actually use those equations. He started saying some conspiracy stuff related to Canada, and I was like, hey, buddy Hoser? Yeah, that's what I hear. I never heard what he said. I just kind of like moved on from the content. Because again, when you look at a subreddit, all the people in the AVE subreddit are trying to talk like AVE, and it really just kind of sours, it kind of poisons the source there. It's kind of like, you know, everybody's doing a Cartman impression, and it sours me, the whole thing. And also, I don't like to watch that kind of content from my peers, because then I'll take on their memes because I think they are engaging and funny and smart and interesting. And it's a form of flattery, but it also makes me into just this giant turkey. And I don't want to do that. I don't want to do that. So I tend to avoid. Yes, say the line, AV. Say the line, Bart. It's something. It sure is something, isn't it? But yeah, so I at that point I was avoiding his content anyway. But crazy conspiracy theories aside, I mean, there was some interesting stuff there back in the day. Taught me a couple things I didn't know before. But yeah, okay, so we trickle charge this thing and then we kick it up into high gear. And when we activate this transistor, it might explode. This might be just the explosion pin. Like if we set off this pin right here, that might just delete the whole project. And everything won't explode. The capacitors are perfectly happy to operate at high current. The capacitors inside of this power supply we know are up to it. We've had it charging before. So everything will be totally happy to do its job, except these two transistors will be turbo fucked. I shouldn't curse this early into the stream. I guess we're 12 minutes in. I think I'm okay, but the YouTube bot will beep boop, curse detected, eliminating channel from algorithm. It's worse than being dead. You're simply forgotten. I don't know if I built this circuit the best way that I could have. I think there's a couple places where it's a little inefficient. Some of the ways that I ran the lines and stuff. It's possible I could have rearranged things a little to make it better. But we got a problem. We got the problem. And that's that we blew up the transistors. And there it is right there. Our little buddy. That connects the 100 volts to the thing, but then it overcurrents the transistor, and then this ended up smelling. I'm pretty sure that's what started smelling. I don't think I see any other super broken... There's a little chip on that diode. That actually... Is that part of the symbol? That's part of the symbol. Okay. You know, they could draw a diode on the diode. That would be helpful if I got like a little picture of a diode. I mean, the band you think of as the band that the arrow goes into, right? So that's the cathode. But still, they could help us out a little bit. This doesn't look blown up. Capacitor's not bulging. I don't think this is what broke. J6. The coil's definitely okay. I think we're okay. Big diode? Big diode looks okay. That's a little sus right there, but I think SS14 right there. Oh, Jesus. That's a heady part number. Maybe you guys skip that part number and just don't use it. Jeez. But yeah, the symbol on the diode, I think that's supposed to be there. That looks like something that's supposed to be there. So, tip 122 looks fine. This one even looks fine, but I think that's where we were getting the smells from. This looks a little worse for wear. We were well over-spec'd on it, though. I think it's just from soldering in. Some surface bounce diodes have a little triangle. I guess that's what that was. It looked more like a company logo, though. I have not previewed this mix, so I don't know if it's really bad or not. Seems a little overly chill. It says it's the My Definition of Chill Underworld edition, so it'll feature a bunch of music from Underworld. Or the Underworld. Maybe I put the diode in backwards? I feel like I can't see a line on it. Is there a line there? This is where I violate my terms and conditions by working on the circuit ahead of time. And having stream start soon up there without it actually having been started. What's up, Justin? Justin Spencer. How's it going? I just used a tool called Mixmoose to sort my 500 song playlist energy. That's the type of energy that I'm bringing to the... I did start another playlist trying to get non-vocal tracks that I could put together to play ahead of stream. And last night I got drunk and really sidetracked by early 2000s trance. So I started just listening to early 2000s trance instead of doing anything useful. Oh well. A lot of songs that I hadn't heard in 20 years, 10 years. Let's be fair. It took me a while to stop listening to that music. Guess we're not really going to need calipers today. I'm going to need my book of diodes, but that's right over there. I'm looking at it right now. Not much to report for my Wednesday. I didn't get as much done as I wanted to. I really wanted to sit down and do audio stuff, just from last stream's little fiasco of people who can't turn their devices up or something, and for some reason bother me about that. And I think that's a troll tactic. I think I was being trolled, but then a bunch of the regular chatters hopped in behind them. So that makes me very self-conscious. I do not like it when people comment on audio, because I work very hard, very, very hard to get my audio right and sounding good and not be abrasive towards the people listening, because I'm a stickler for that. I mean, it's one thing that like streamers will do. They'll spend a lot of time on their sound, and then somebody will just start up their stream with like a lav mic that they're holding in their hand and just go, hey, how's everybody do? And people love it, right? Some people just headset mics that are completely unengineered. None of the frequencies are messed with. Everything is just somebody's headset mic, and they'll have 5 million people watching. I spend hours and days perfecting my audio, recording myself and listening to it back. I've gotten fully used to the sound of my own voice on a recording. It's still kind of, gives you a little twinge, but you live with it. You've learned to live with it. And I've done all of that work, and it was hard work. And I have 5 viewers. I don't know, it's just a thing. Maybe I do need super shitty audio. Maybe that'll help. Or you just buy the $400 Shure microphone that everybody has. But we're here. Yeah, you guys are here, and I appreciate that very much. But yeah, I'm going to have to, either between today and tomorrow, if I can stomach it, or probably better yet, tomorrow, because it'll just be me and Willow in the house for the weekend. So I can spend, either tomorrow I can spend time, or over the weekend I can spend time. Bring the mixer over here, because I want to use that mixer. It's already plugged into the game mic, and I've already gotten it tuned up with the game mic. If I can get similar performance from the M Audio filters on this lab through that mixer, I'm moving over to it, and then I don't have to worry about VST plugins. I'm looking forward to your new album. We mixed down for 7 years, and then some asshole records on a cassette tape and becomes famous. It's less about the work you put in and more about the how people receive it. You get lucky. I was looking at the new M Audio tools, the free ones, and I have no idea which ones I would even use. I think I need to separate myself from the dependency on the computer tools and have the mixer be my audio. That way, if I call into somebody else's show and I'm not on camera, I can send that audio from the mixer into Discord, and I'll sound the same. I'll sound the same no matter what show I'm on or computer I'm on. So yeah, I don't know if I'll be going with M Audio. We're going to be working with this thing today, though, which is super crazy. A multiplexer matrix. There's all kinds of tools in the M Audio stuff. Magic, analyzer, auto pan, auto pitch, band pass, bit fun, no idea, MCC generator. None of those are really that useful. Channel matrix, probably not that useful for me as well. Really, I mean, these are VSTs, and what I can do with the VSTs is put them into OBS as filters on the sound source. So I can go into OBS and put it as a filter on the sound source, and then it will edit the audio before output, right? That's where these sit. So a lot of these weird effects and stuff probably wouldn't really affect much. Like channel matrices at the very last step before it outputs is not going to be useful. You can do bit crush. I don't want to do bit crush. The mixer has audio effects that I could put in. How you would sound an auto tune. You don't want to know. You don't want to know. So it'd be compressor would be one of them. Loudness analyzer. Metronome. Noise generator. My notepad. Why do I want that? I don't want that. MO scope. That's an interesting one. Don't need a phaser. Don't need a ratioer. Recorder. It would pretty much just be the... Not wave folder, is it? The compressor and then an EQ. There are ones you pay for, too. Those are the ones up there, but... And bandpass might be good enough. Oh, the MEQ, yeah. These would be the two that I would get. You need noises added over your voice? What, like penis music? Could this also be done with VCV rack? Probably, but I don't want... So my whole thing is I want to get it away from the software. If it's connected to that mixer, that would be great. And the mixer can do like a de-esser too. It has extra features that I paid for. I paid for that goddamn mixer. I should use it. I want to have all my microphones going through the mixer. So if I can make the two independent microphones for me and Julian to sound like these do right now, and that's just a minimal amount of EQing and then some compression, and the compression's really important so that, you know, shouts and power tools and stuff don't blow up everybody's speakers. But if I can get that working, which I should absolutely be able to do, I just need to sit down with a big pot of coffee and do it. If I don't stream tomorrow, that'll be what I'm doing. That'll be what I'm doing, and I will have started it later than I would have liked to, and then not been able to open broadcast in time because I'm still messing with it. That's what's going to probably happen to stream tomorrow. I may not stream. I could potentially stream Saturday though, because again, it's just me and Willow here, so I can do our thingy thing pretty heavily. I do have a lot of homework that I need to do though, and that's the homework meaning the unfun stuff that I have to do for the projects that are bigger than what we're working on right now. The big thing would be getting some progress on that mixer. I need to sit down, rebuild the circuit, because I need to poke into the circuit to figure out what's going on, and if I can do what I think I need to do in order to get all the parameters that Julian wants out of the thing. I'm starting to forget what they were. That's the bad part. I have them written down. I have stuff written down. I would have to use virtual audio cables too with VCV rack. Oh, Eurorack simulator. I'm not sure how audio in and out works in this, but I definitely don't need all of the functions of VCV rack to do the audio stuff that I want to do. This is a little bit much. Oh yeah, this is still on the 3D printer. I don't think we're going to be printing anything today, unless things go totally sideways. I think I said last time, I had somebody in Tomatoes chat say, "Whoa, oh bother, your content is super cool." And I'm just like, oh no, don't talk. Don't refer to me in here. I watch other people's streams and I don't turn off the partner badge when I comment, and some of these larger streamers really don't like it, because I guess traditionally the people with partner badges were like their friends, and so they can't easily parse chats from their friends in their chat when other people have the badge. It's kind of cringe when you break it down, but that's the way some people are. So people acknowledging like my content on somebody else's stream is, ugh, don't do it. don't do it. Don't do it. I appreciate the, drop to the DMs to do that in somebody else's stream. You got to pick one or the other, either hardware mixer or virtual mixer. Everyone I've seen tries to use both. Turns into a nightmare before you even begin, yeah. I have 2 physical mixers because I'm terrible at selling old gear. I'm just the worst, right? Do you have a non-partner sock account? I'm not big enough to do that. I'm not big and cool enough to do that. If I did, if I was super huge and it would totally ruin somebody's chat if I talk in it, I generally get completely ignored, it's a blessing. So I can drop down as oh bother and leave a comment, and somebody will say, sometimes they'll see the partner badge and they'll be like, oh, another super famous streamer. And I'm like, no, it's just me. I basically cheated the partner system to get in. I didn't actually cheat. You guys had a big push during the pandemic, and I was able to justify the 75 users over a month. Although, the viewership growing in Twitch made that kind of a very low ball sort of requirement. It's more like 100 average for a month. and then they'll partner you. But if you're over that number, you basically apply, and then you apply a second time when they reject you, and then you get in. And that's it. So some streamers, some of the larger streamers have been known to be like, it's not a large. Actually, the cool thing about it would be if I went to a convention, I would then be able to get into the partner area and be like this little wiener among like gods. I would have access to them. Maybe they'd give me a shout out. How's it going, Celia? How you doing? Me too. I can't sell old hardware. I might use it one day. Listen. It's a plague. It's horrible. Julian comes over and he's like, "Why don't you just get a 4-channel Focusrite?" And I'm like, I can't sell the mixer. I like that mixer. I don't know. For some reason, Julian was under the impression that in your like station, like for instance, wherever you're running OBS and you're streaming from, you're not able to have more than one audio input, which I think is something that came from other computers and other hardware, because I've never had problems with that. With OBS, I mean, you just add the audio devices into the scene and they're there. They're all there and functioning. So I actually got something that allows me to break out the channels of that old mixer, even though you can't, for some reason, you can't pan the channels all the way left and all the way right on that mixer. And I don't understand why that's not a thing. Because traditionally, when you have stereo inputs, you would put them in 2 channels and you just move those in tandem with one another, right? That's how you do it. So you always did it. And they've got 4 mono inputs on that thing. They do have a stereo input. It's for a cell phone, but it is a functional stereo line input, but it's only one. And I wanted to give Julian and Dave both stereo inputs, which would be all 4 of the faders on that mixer. Been enjoying the new RuneScape Dragon Wild survival game. They seem to have kept the aesthetic of RuneScape while also making it look completely modern, which is weird. It was really... I saw Benji, King Bendrick, playing that earlier today, because I watched some of those channels when I'm setting stuff up in here, waking up and reading all of my emails. Oh, bother becoming a talk show host soon? Man, I could get one of those big boy mixers. That would be super cool. I could get one of the ones that exists like on the rack, and then you have the like panel separate from it. That would be really cool. No, I'm not cool enough to have a talk show. I need followers and viewers. I don't get those. We got, at most, we have 75 people in here. Which is listen, that's a mind-boggling number for me. That's a lot of people, and I'm super happy to have you guys here. But it's not, those aren't typical Twitch, like those aren't like healthy channel numbers, you know? If we had 3 to 4, I would be in an extremely happy place. I would be in a very, very happy place. And I shouldn't talk about numbers so much, but when you're down here with the little guys, and apparently I am one of the top, what was it, 20%? What was that email? Hold on, I got an email from Twitch that said, hold on, let me check my email. Fluke Biomedical. Did I delete it? I probably deleted it. Yeah, I think I deleted it. I don't know where that email is. I think it was the top 25% or something like that. It was some ridiculous high, like ridiculously small percentage number. But it might have been 2. I'm not sure. Down in the number mines, yeah. We're digging out viewers one by one. You can't prove that I'm here. No, I can't. I tried. It was a big philosophical discussion. Yes. This thing scares the shit out of me. I'm going to be honest. I do not like working with this much capacitor. Yeah, what is now? What is here? Fluke Biomedical, same Fluke as the one that makes the voltmeters? Yeah. It was during a time when I was looking up biomedical sensors. And Seed Studio has a bunch of those like non-contact heart monitors and stuff like that, like blood pressure and stuff. I was wondering if I could get biomedical information up on screen. You guys could see truly how unhealthy I am, or how my blood pressure is terrible. We're here for the beard and the dog. She was outside of the shop earlier. It's just as soon as I touched this stool, the 1960s stool, it made a big hunk noise when I moved it. She decided to leave. She just, I don't know, she's tired right now. She wants her quiet. So she leaves. I wish she would be more of a co-host like she was when she was a puppy. When she was a puppy, she was down here all the time. I loved it. It was so awesome. She'd come down here and be like, "What you doing?" And I don't know what happened between then and now. I think she discovered that she really likes barking at the door. And she also likes cold air, which I keep this window propped open because I like cold air too. We share that affinity. And I guess she would use this as a port to listen to the outside. But the front door is probably a little bit more transparent to audio, and she can see what's going on. So she does not come down here as much anymore. Still give her plenty of walks. It has almost been 3 years since we got the dog, and I don't think I've lost any weight. I don't know what the deal is with that. I think it just has to do with my tank of metabolism being just the worst for losing weight. The last time I lost the weight, I was on external testosterone. It worked brilliantly in both motivating and ensuring that I was capable of building the muscle to lose the weight. And I think my borderline low testosterone keeps me from making the systemic changes, whether it be through fatigue or just simply being too lazy to get on the bike. But 2 years of walking the dog, 2.5, 2 3/4, 2.99% years walking the dog, and I have not lost much weight at all. I do need to get on the scale. I haven't looked on the scale, but at least superficially, I don't see anything happening there. I know I'm not dieting, stuff like that. If I'm going to get back to the biking. The bike is sitting in the other room. It has a stand. It has an oil stand that I can put it on. I need to cancel the gym membership because I haven't been to the gym in eons. But then I need to set up that bike, and I need to get on it 3 times a week for an hour. 3 times a week for an hour that was the formula that allowed me to lose all of the weight that I had. So. Why are you just laughing into the, what's so funny about what I'm saying? I'm actually sharing my thoughts on progress. How far do I walk the dog? Well, she doesn't like to walk very far. We have a half-mile circle of the neighborhood, and I try to take her on the full half-mile circle, but she ends up just kind of puttering around our immediate area. But she does a combo of running and walking and playing and stuff like that when we do take walks. It's enough for a corgi, but it's not enough for the human. So I was dog sitting for a friend for a month and a half. He was over there in Imperial Land. I felt I got so good shape. I was walking his dog twice a day. That's awesome. I am laughing because you are not trying. That's very mean of you. Thank you, I guess. Taking the dogs for walks is better than doing nothing. So, the trying happens when I set up the bike, and I'm close to doing that. When more burnt capacitor? I don't know. Hopefully they all survive today. They're all at risk, these little snappy little bastards. They're all at risk. I think mostly we're going to fry a transistor early on. I'm going to set up the circuit kind of in full regalia. Just everything that I put in here, we're going to put down on that board. Put all this stuff down, and then we can selectively activate it. Yeah, I don't really like trainers. What I've done is I've done a lot of modifications to my old mountain bike from like 2008. It's a very old mountain bike. Yeah, that's what IEDs are. Yep. It'll smell and leave a mark on the desk mat, depending on how it blows up. Some of them blow up vertically, and then you're just left with little bits of paper all over the place. What's the voltage on the big caps? It doesn't actually list one on the cap. It gives a watt volt rating, so it's 200 watt volt. I don't know what that really means. I've never seen that. But these are Nishikan 15,000 UF So 30, 45. Yeah, I have one of those fluid things that you put your own bike on, and then I've done stuff with like the handlebars so that I can like lean up against them. It's an old bike, and then in the middle I put a tablet holder so I can put something on for the hour that I'm biking. That stands for working voltage, so 200 volts. Well, we're at half of the voltage of the caps, so those will be safe. Now, no matter how much we're torturing them, I don't know what the amp rating, the feasible number of amps this thing can pull and push, but I think we'll be okay. One of the things I'm concerned with in the long term for this circuit is the JST connectors. We are well outside of the ratings of the JST connector, and they've got kind of a thin metal piece on them that might get pretty hot. Now I need 2 of the modules in series. We get plenty of throwing power from this thing with just these caps. These are big caps. I do have 2 more of them, but they're inside of a little enclosure. And I think that's the total maximum number that I have. I've had 5 of these traditionally for... These are the capacitors that went with the 12 volt, the super duper computer 12 volt power supply. These... are basically there for the 300 volt line that goes between negative and some kind of a half tap and then positive. And for some reason, the 200 volt ones are perfectly fine to use. I don't know. But they worked faithfully in that big power supply for a long, long time. And they would be used in the more modern one, too. Sound like the ones I found in an old C64 PSU. It had 3 angry caps that shocked me the moment I got in. I would like to avoid that, so I've put them on this prototyping board. It means things are a little bit close by. There's, the spacing isn't exactly preserved for our 100 volt shocking line, but then again, I've seen stuff this close that uses 120 volts, so I think we'll be okay in that regard. But I don't want to be anywhere near these things when we're charging them up and setting them off. And again, that's why the circuit works the way it does. It activates, it actually puts the trickle charge of 100 volts onto those caps intentionally, and then releases that connection when it fires this thing off. I miss electronics projects. I need to start some up again. Why does it say stream start soon if it's already started? Hey... Did this get larger when he said that? Did this activate? I think it did. Did it? Did we see it? I didn't see it. No, it's broken. What's going on? Hey. That should have worked. We had this working before. Contains start soon. Did it get the message? Ooh, love me some Underworld. Let's see. Raw event. Broadcasts. Chatter, Celia Russell. Text. Message. PSU at 3 big caps. So that would be my chat message, and then this one would be... And was it a first time? It was not. So this might be Destructo Labs. That's Pseudo Maze. All right, that's the one before it. I don't really know the lyrics of this one. Damn it! Still wrong person. Where? Oh God, I lost track. It might be here. Destructo Labs. Need to start some up again. Also, why does it say stream starts soon? Ah, it's purple. Gifting a sub to Lead TV Live with 116 under her belt. Damn. Celia Russell, thank you so much. Appreciate that. That's the status light that we just built, going purple to indicate that a gift stub came through. Thank you, Celia. That is so many gifts. Very, very generous. Starts soon. I mean, that's contained in there. contain start soon, on and off, delay, and then it goes into the batch request for, yeah, it starts soon and then starts soon. So start soon is set here, payload, overlay scene. That's all. Yeah, that should be, and it detects whether or not it's going on. Yeah, I don't know. Rock and roll. Start soon. But if it's like, hey, Code Rush, trading with a party of 4. Thank you, Code Rush. Do we have anything happening for raids? I don't think I do. Raids. Oh, it did go purple for that. There we go. We got Purple Lady. What's up, Code Rush? How you doing? So, if I do start soon with a question after it, oh, because it's start soon. So we'll add one to it. Where do I do that? Right there. Contains fixed. Need to cover my linguistic possibility. There we go. Back to being petulant. Who needs transitions on that? I could use a transform and make it huge. Make it actually like pull it out and become big and then have it become small again. But this is the easiest way to do it, is just to have 2 scenes with the same graphics in it, and one just activates when somebody says that. Back to business. Back to business. What did I accomplish yesterday? I don't think I did much. Yeah, that's all the Node-RED stuff. We finally, one of my moderators sat down with me and actually like really helped me iron out what it took to get this thing working. The Node-RED Twitch event sub node. This thing is very cool. It's very powerful because event sub is all of your chat messages, it's all of your subs, it's all of your bits requests and stuff like that. And so what we did is we took this, and I'm gonna burp. We took this and we attached it to Node-RED, which is running on my file server. And what this will do, at least initially, is activate these the Tasmota lights on certain conditions. So hold on, that's every scene but the one I needed. This light turns on and off depending on what OBS scene I'm on. The idea light, if somebody says idea, this thing lights up. If they sub, it'll change to red for just 2 seconds. If a gift sub is given, it'll go purple. And if there's a raid, like with Code Rushed, then it goes purple. And it just tells me, that something's going on. The idea is where it started, and then we've expanded its capability over several different systems. And so finally, I've gotten OBS to really listen to it, and so I can do overlay graphics that are based on chat, based on raids, based on bits redemptions, anything, and even stuff that involves an ESP8266. The reason I use the ESP8266 is it's a very capable little bastard. It's like $1, less even, I don't know, it depends, all the tariffs, everything's going to change. These ESP8266 are easy to get. You can get tons of them at a time. You buy them by the bushel. They run code reasonably well. They're no ESP32, but they are a pretty good means by which to run code, right? And so what they can do is get on your Wi-Fi. And when they get on your Wi-Fi, they can listen in to MQTT. And MQTT is just a messaging protocol, and it's what all of these Tasmota lights work on. So if we have an MQTT broker already set up for Tasmota, we can use that broker to have its own channels for all the little ESP devices. So when there's something like a points redemption, I can make it set off one of 9 farts that are inside of this box. This thing was a dollar store fart noise generator thing. 3 Mares sent it in. It was fun and funny, but then we made it automatic. Why was I peaking so hard there? Weird. Make it automatic. Automatic. Yeah, I don't know. The compressor, I guess, sometimes like misses, and so louder stuff gets through. All right, let's pause the music. So anyway, that's the system that I've invented here. You'll never get fart spray. I'm not going to attack myself with chemicals. Anyway, so that Node Red stuff leads us to the project today, which is actually to work on a device that's going to, and again, unhinged people sending me things without my request. I got sent like 250 million of these little physical emotes. They were like, hand these out at a convention. I'm like, have you seen me? I am the fattest man in the world. I do not want to walk around a convention hall. Actually, moreover, I'm diabetic and I don't want to get a cold, especially post-pandemic. One day, maybe I'll get myself out to a convention. I'll hit the exercise bike for a year, and yeah. 5 is rivaling on 7 loudness and length, yeah. I don't want to walk around ever. I don't mind walking. It's just convention hall stuff. So, one day maybe I'll get out to passing these out. But for now, I wanted to find a kind of a fun, funny project with these. And so the thought is I've got a lot of them, so maybe we just toss them at me during stream. So toss these at myself during stream, and so we make a little solenoid kicker that'll just kick these up into the air. And you and I could be twins, but I think I'm fatter. Large Engineers Unite. I have a lifelong friend that has a similar build to me, and we used to go to shops, and people would think that we're brothers, and we were like, no, we're not brothers. I know what that's like. But anyway, so what we're doing, we can overpower it and bounce them off walls. Okay, we've already overpowered it. Listen, the best way to get something very momentarily to happen at great destruction and much worrisome and all the risk and whatever else you'd have to make your Twitch stream look cool and popular and punchy and fun, we've done that to this. This is the solenoid. I've mounted it on MakerBeam, and we probably need to come up with another mount for that. But we did some initial testing when I was building the frame for this thing, and it turned out moving this thing all over the place was really kind of very risky because it was on solderless breadboard. So I've taken the plunge, and I've taken a perforated prototyping board, and I've put all of our stuff down. I tried to keep all the high voltage stuff over here because remember, at 12 volts this thing is able to hold the solenoid for extended periods of time, but it really doesn't hold it all that tightly. It doesn't kick it into one direction hard. So instead of allowing there to be appropriate voltages on it, what we've done is we've taken a Nixie power supply that can only provide a little trickle amount of milliamps, and we have attached it to a massive capacitor bank. Therein lies the rub. When we attach the transistor to the little cap bank, when we originally had the circuit running on the perforated on the solderless breadboard, it was working just fine, but there was 9 volts that would stick on this line. And I don't know about you, but I don't really appreciate having high current 9 volts sitting on my devices. It would hover at 9 volts, and then it would charge up to 100 volts, and it would kick off just fine through the TIP 122. TIP 122 can handle 160 volts and very high amperage. That's why we're using it. It does get a little warm, but not significantly. We haven't had a long test period for this yet. So I decided to put a little high voltage transistor. I actually opened up my book of transistors. I've got these little binders that are filled with sample parts. They're actually kind of awesome. You can get them like on Amazon and stuff like that, but they're these little binders, and they're full of surface mount parts, just chock full of them. So we got resistors, we've got capacitors, and I have transistors. And I opened up the transistor book and looked at the last page, and it said SNE5551. And I said, 555, I hate that chip. And so I looked up the data sheet, and it turns out I immediately chose the exact one that I would need. What was it? SN? Yeah, SN5551. So the SN5551 is for things like high voltage displays and stuff. Where is that? No, not Daikin. Datasheet. God damn you all, datasheets. From Own Semi, although we should find the surface mount. Mauser? Yeah, here we go. Oh, MMBT 5551. Good book. OG 0603. You know, first chapter drags a little bit, but so the 5551 is 160 to 180 volts, and the EB voltage, it says it's 6 volts. I mean, it needs 6 volts to go off. Wait a minute, because we're giving it 3. Huh, this might be the problem. Oh no, that's the breakdown voltage. Yeah, saturation voltage is 0.15. Okay, never mind. And 1 milliamp, 10 milli, yeah, 1 milliamp. Yeah, okay, so anyway, the point is, yeah, that's when it blows up. Okay, we were giving it 3 volts, so it should have been fine. 3 volts through a 1K resistor. So I've got these two stacked up like this. This is the what we need to build. Basically, in order to charge the circuit, we have a fixed current limiting resistor on this circuit. So the current limiting resistor is going to be 125 milliamps, which is a lot more than the 80 milliamps that this thing can handle, but it won't totally dump all the current in and blow this thing up. This thing can only handle about 600 milliamps, which we're well under. So we're going to charge through that current limiting resistor, and then at some point when this thing is discharged a big capacitor that it has, once it is discharged its internal capacitor and charge the big capacitors with it, then we can activate this transistor, and that'll produce a short across the 2 terminals and knock out the current limiting resistor, and then it'll charge much faster, because otherwise it would take 4 seconds to charge. So if it takes 4 seconds to charge, that's outright. We hooked up the Node Red stuff so that when the emote was entered into chat, the idea lamp would turn on after 4 seconds, and it was an excruciatingly long amount of time. So instead of allowing this thing to charge through 4 seconds, we trickle charge it for just a couple milliseconds, and then we'll hit it with the full charge. But you know, in order to test it initially, we'll have to give it the full 4 seconds. So let me get my book of NPN transistors, and we will get to putting this guy, modifying this guy right here, and making it work with the full extent of this battle station's capabilities. Oh yeah, that was a really hasty connection yesterday, or the other day that I made. This is like terrible. That one's not populated, right? No, it's not good. Just looking for any glaring mistakes that I might have made, because we definitely smelled burning electronics when this thing was done last time. All right, so let's here. It's the wrong camera. I keep doing the wrong camera. And all these projects that I do, I know, like Chad always gives me this crap about not finishing stuff and not getting back to working on Burn the Subs, but all of this is in service of getting back to working on Burn the Subs. I gotta keep stuff exciting and fun and quick, and I gotta keep the variety going so that we have all the pieces we need when we go back to Burn the Subs. So I've been getting nice and familiar with getting stuff running in Node Red and allowing me to have all of this little automated stuff that's going to lead in to Burn the Subs. 4 cameras and a thermal imager. I would like more. Some noisy ones too. That last 10% will kill you every single time. It is the worst part about doing stuff like this. My motivation for doing that last 10% is that I'm streaming it, and I need to keep it fun and exciting. So I need to finish things, and that usually pushes me to getting that last 10% done. But it's a monster. It is a monster. All right, so these are diodes. Why did I get diodes? What is wrong with me? Hold on. Wrong one. Wrong one. Wrong one. Transistors. Yeah, I would like to have some like composite cameras and maybe a composite switcher to give kind of a filthy aesthetic, because it's always fun to have kind of an aesthetic to your stream. I need to come up with some better framing for everything too in stream. I mean, not like the main video is fine. It's just this could probably use a frame on it, or just soften up the edges or something. I wonder if there's a plugin for that already in OBS. Probably is. 2 transistors, 6 feet apart. The 2N5551. So let's see what our pinout is. Our nonsensical pinout for surface mount transistors. It is very annoying to work with surface mount transistors because their pinout is so that things go on the circuit board a little more cleanly, but it doesn't help somebody like me that gets distracted very easily having the symbol for a transistor be a bar with a line on one end and 2 lines on the other, and yet the transistor has the base emitter and collector off phase. It's the emitter is over here, the base is here. You would expect base to be here, but nope, that's not the way we do it. Stroke, glow, shadow from OBS project. Stroke, glow, shadow sounds like some weird that sounds weird. Oh, that's interesting. For text, I kind of like my text being gross though. Oh, I see. So you could do it. You could drop a shadow on your frames. That's interesting. Oh dear God. No, I will not be doing that. But yeah, it looks like okay. So it also does the softening of the frames and stuff. That's cool. Yeah, maybe I will. I'll leave that page open. We'll put that all the way over here. Yeah, you can drop a shadow on any source. All right, so base emitter collector and base collector emitter, right? Base collector emitter. So you would really expect number 2 to be the collector, but 3 is actually the collector and 1 is actually the base. It's ridiculous. Anyway, that's just how they are. It's something to watch out for with surface mount transistors. And actually, sometimes they could just have any pinout. It could just not be anything that you expect. So we know what the deal is there, and I'm pretty sure that this is what broke when we tried this last time. And I got very significant burning smell from it. The base is connected to the base. Yes, that's correct. And that line is the positive? Yeah, and then the other line is the... Wait a minute. I gotta think about this. Okay, so positive to the capacitors. All right, let's get this one out of here, and we'll have to figure out what the circuit is actually gonna look like. This is tough because there's a lot of stuff in this area to get in the way. Let me get my light in a little closer, and I don't think this thing fits in the normal vise. I had it in the big vise, but I kind of don't want to mess with the big vise. I'll just hold on to it. The problem is industry can't decide where the pin 1 is. They partially solved this by instead calling it 1. They called it BCE. Huh. I'll clean the iron here. All right. I thought it was just so that you could have your pull-up resistor sitting across these 2 pins. I should probably rip up this whole portion and redo it, because we're a little bit constrained for space here, and I need to move back in order to install 2 transistors instead of just 1. So let's get the 1K out of here, and I'll move the purple wire, and then we'll have a little bit of room to kind of author our switching setup. Oh, I don't have tweezers. I don't have my tweezers! My hands, they feel weird. What's happening to me? All right, so let's get the solder out of there. And I guess the best way to do this is with the Engineer SS01 solder sucker with its silicon tip. That's the important part, is that silicon tip is what gets you there. It's really, really, really quite useful. What is that hole doing there? Was that already in there? I think it might have been, huh. I thought I chose this breadboard because I didn't do anything with it, but I think I pre-drilled a couple holes in it. Oh no, that's there. Okay, so that's mounting the power supply, so we can't build in that area. Yeah, I can't build in that area because there's a post there. Hello? Okay, there we go. Oh, I think there's something on the other side there. Or not. There's nothing there. Okay, so we should be able to remove that. And the one next to it is our high voltage. God, I'm like hot and cold at the same time right now because there's a fan moving a little bit of air, but it's hot with all the lights on the desk and everything and all the stage lights and stuff that I use. So I'm like sweating and cold at the same time. This isn't good. It's not a good scene. All right, plenty of solder that this thing can now grip and pull. Nope, I think I missed. Yeah, there must be something on the other side of the board there. I thought this was a blank pin right before the header, though. Oh, no, it's this one. That's where we are. So this is one that can go. Oh, yeah, because there's just this band here, so I just need to remove this. We may have to pull this whole circuit to another area where I have room to build. Which is weird, but I guess it's our 100 volt line. It's not going to lose much steam by moving over to a different part of the board. And I'd rather it be a little bit more spread out than we are right now. Are you how Kafka-esque? I got to use it. I got to say the thing. He did it. He said it. He said the thing. He said Kafka-esque. Okay, so the positive line that goes to the capacitors is going to be interrupted by our circuit. That's also the line that goes over to the voltmeter. So this right here and this right here is what we're switching between. So that means that if I wanted to put two transistors here, I think I've run out of room. So I can put the transistors earlier and have just a little tiny high voltage wire go all the way over here. And if that wire explodes, then it is a fusible link. If it survives, then it is not a fusible link. But we're going to treat it as such. So let me get a decidedly high voltage wire. What's the color for high voltage? Yellow? Would yellow communicate properly that this is a high voltage line, not a high current line? White would probably be the right color, but I already have the white wire there that goes to the tip 122. So let's do yellow. Wire color is not incredibly important, but it can communicate to me later on what is going on. So in my multiple voltage systems, I use black wire for ground, red wire for 5 volts, yellow for 12. The same conventions as computers. And then if I've got a 120 volt system, I will use white or blue or brown for the voltages. It really messes you up when you get to car wiring, because in car wiring, there are no standards. There's just nothing. You have to go in through the manual and see what they decided to do. It can really mess you up. So our high voltage source coming from here will go through the yellow wire and up along this lower voltage wire that goes back to the microcontroller. And it just goes right there. Straight over to the next row. Why is nothing happening when I do that? I don't think the heat sinking is that good in this area. I'm going to have to manipulate that wire just a little bit, but right now it's just kind of hanging. So this is going to move all over the place when I solder it. I really need to re-aim that fan. I'm getting a little sick of the heating situation over here. There we go. All right, so now that's connected to high voltage. And then our output is going to be right next to it, I guess. It's going to be the positive line there. So that'll be this cluster. So our send wire color is what? We're just going to pull the whole circuit over here, and we'll just do that right here. All that switching that we want to do. Instead of packing it as tightly as I can, we'll spread out a little bit, have some room to operate. I guess blue wire for this, or I could make it yellow as well. I think it's better to differentiate between the two. So I'll use blue, even though we're not to wiring standard colorizations here. My only fan? It's my floor fan. No, my largest fans are the ones that are in the surface mount. They're the 10mm fans. They're kind of cool. Maybe we should put one on this. Would it do anything? Probably not. That resistor really bugs me, how it's like slid over to the side, but I can't do anything to move it because this thing is like fully meltable, so I can't come over here with like hot air or anything like that. I just have to live with it. All right, so the trickle charge goes out from this. So I'm just going to put it, I guess I'll put it here, and we'll have to bump it up so it avoids the 6-pin surround that protects the brass post that'll sit there from the power supply. And that just goes right over to its, yeah. Maybe better probably to pick it up down here like that one, but no, that's okay. That's all right. Yeah, because then I would have the wire on the underside of the board, and that would be a little weird. I have a couple wires that are on the underside of the board because I don't have any good standards with this kind of stuff. What I need to do is buy a square pad solder prototyping board. Square pads and then no pads on the underside, because the underside is where I'd route all of my wires, and then the square pads on top are really good for surface mount because the surface mount usually has square pads and it gets them a uniform distance, so you can do shenanigans like having multiple surface mount parts that are near each other, like on the accessing the same pad. And somebody found it. Somebody found that proto board a while back, and I bought a bunch, and now I don't know where to buy it. It's this stuff. It's the same stuff I made the solder iron holder on. So you've got no pads here, and then square pads on the underside. This is the stuff that I should be working on. It's just this round hole type is cheaper and easier to find. All right, so purple over there, D1, 2, 3, and so D4 is going to be our new activation. Are we already using D4? What's going on down there? I think we're only using D1, 2, and 3. Let me look at the code real quick. That requires me to open up. Oh no, I've already got it open. I've already got it open because I haven't restarted this computer in 900 years. And there's a Windows update that it wants to push out. I'm not letting it. Pins would be D1, 2, 3, and then define bypass is D4. Just save that. So the bypass pin is D4. So we need a wire that is going to be D4. We're using purple, we're using white. I need to get more wire colors. If I use blue, that's going to match the other one. We've already used white, black is ground, red is usually power, but I guess in this case, we will use red because I'm already using purple. Pink. I don't have pink. These are the only wire colors. I just listed them off. Where did the red wire go that I just cut? There it is. We'll use red. I need like 3 more. Motion detected. They're doing, the HOA is doing all the yard work right now. So finally, I will have a pinecone free road and I'll be able to do the high speed stuff that I wanted to do. Since it's summer is upon us and it's warm out. So I'll be able to do the RC car run. Without the gyroscope, I got 30 miles an hour, but then it hit a curb and exploded. The body cracked in half. So now I will be able to do the high speed run with the gyro and the GPS and figure out how fast that thing can go. We need more wire colors. I can look for it. I can Google it. I don't know how consistent it'll be because I bought all these at the same time. With everything plugged into this, it's like hard to rearrange. Oh, we're going in the other direction. Wait a minute. The other direction, the other direction, the other direction, the other direction. Don't you tell me to smile. Okay, let's see. I'm gonna unplug everything. Unplug the things so I can work on the circuit. Oh, I smell burning. What did I burn? I think I burnt the end of the wire. These are silicon jacketed wires, so they should withstand the a brush with a soldering iron. Wait. Oh yeah, this is one. Damn it. Everything is moving. I'm used to having these on a vise. And the vise would take up some of the momentum here so it wouldn't brush all over the place and move while I'm trying to solder it. I shouldn't do it this way. That hurts the end of the wire there. Okay, so we have our trigger timbers. We have the 2 lines here, D3 and D4, and then we have our 100 volts in and our 100 volts out. Now, since we've done calculations on all this, it seems as though this is going to be like an eighth of a watt going through this. So we can use 0805 resistors. This should be just fine for the current limiting resistor. So if our 100 volts is coming in and we just have it go like here, well, you can go a little closer because this is the insert point, and then we'll have a transistor and another transistor. Maybe if we do high voltage over to the side. Well, no, I don't want it to be towards the edge of the board. Maybe that's a really bad place for 100 volts to be sitting around. So maybe we'll just move it in a little bit and have it in here. So we'll have the insert point here, and then we'll have our 2 transistors coming over this side. So I'll probably have to snake these down and around. And then this one's the output. So what's that going to look like with 2 transistors? Well, I could actually keep it up here. I don't want to get near that post, though. I think maybe I come down here and we just do input and output like that, and then I go 1, 2 with the transistors. What do they look like? So that's this. And the base is the lower pin. So it goes collector, emitter. So at the end of the 2 emitters, Where'd the other one go? Here it is. Collector, emitter, and the first one gets the resistor. So we're down here. And then this one, collector, emitter. Come on. And this is the one that blows everybody up. So what I could do is twist them like this so that they're on these two rows and not this outside row. And then blue would have to go all the way down to the bottom. Unless I do them like this. But then the bases are over there. Yeah, it would have to be like this. It's up on this row. I do want to spread it out. I want to make sure that it's clearly set up. What's going on upstairs? There's weird noises filtering down from on high. Yeah, so I guess it'll be these three and then these three and then resistor outwards. I mean, I really don't want to put the 100 volts all the way out here. I don't want that to be, I really want it to be over here. So maybe if we reverse them and instead we send the initial 100 volts all the way over on that wire and do them here like this. That kind of tucks it in and it gives me room for my resistors. Okay, so we'll do it that way. Let's get that soldered in. I'm going to put a smaller tip on the iron, just slightly, so I don't feel like I'm using I don't know, too big of a paintbrush. If this works, I'm going to be somewhat surprised. Maybe not fully surprised because we did run a lot of numbers to make it work. But if this works, that means that we can kind of put this project on the back burner for a little bit because I'll have figured out all the circuit elements. It would just be a matter of doing the layout stuff. The physical like loader mechanism stuff. So we're going to be outputting here. There will be a little bit of separation for the post that's all grounds. So we input all the way over there, and then this wire is going to go up and around and then down this one, and it'll connect under the board. This is way too long. Okay, yeah, we'll make that decision now. I'm going to cut this right now so I can actually use it. So that one goes down here, and it'll go over one. Well, I could have it go down here and then it would push these wires up. These should be pushed up a little bit, like to there. Yeah, we'll do that. I'll have it go down here and go, nope, a little bit more room. So here, and then it goes down to this. Get off my board. Get off my board. And then the bleed resistor will have a little bit of space as well. Yeah, that kind of pushes everybody up a little bit, which it needs to be. So that one goes in there, goes straight down, one row. Just take that, clip that. Can you get fingernails down there? I think so. Or I could try this really risky method. You can't grip too hard or else you'll snap the wire off. There, I think I got it. Although I did push that too far. This wire might get pretty hot in operation. I mean, it really is only doing 80 and 100 milliamps, but when the full bypass is activated, I don't know how much current is going to be sapped away from the power supply. Because I really don't know what that capacitor is capable of. Okay. That's our first one. What the? I went the wrong direction. That's stupid. How stupid. It's supposed to be going that way. That was really dumb. Oh well. It's not like it's undoable. Undoable. Not undoable. Inundoable. Indubitable. It's a double, which means it's got sugar at the end of the brew. Not at the end, it's got sugar in it to just bump up that alcohol content from the yeast. Don't get me started about triple, double. Base is loaded. Okay, so that's going to be the collector, or sorry, the emitter of the last one. Let me just clean up that extra little solder blap. Solder blah. Yeah, it's good enough. Okay, next. Now I can actually put the transistor down before I lose them. They're just rattling around on the desk. I think I just lost one. There it is. Working directly on the desk instead of on the vise is kind of very annoying, just because stuff is prone to moving all over the place. So the emitter, which is the one that's above the base. So viewing like this, we have collector, emitter, base. I want to make sure we get those right, because this thing is doing a fairly high voltage operation, very close to some very sensitive low voltage operations. So we get this like this. And this one's the second one, so it does not have the resistor going across it. The next one will have the resistor up top, going across these two. And that's going to be an 800 ohm resistor. Not a lot of resistance, but it's what it takes to limit the current. Put more bass in my headphones. Actually, I think the current limiting resistor should go below. That would be a lot easier for me to solder, but I would like to be able to see everything all at once, so maybe we won't do that. I don't like to kind of double side these prototyping circuits, because they're prototypes. They're not, you know, they're not fleshed out. Let's get an 800 ohm resistor so we can put that in at the same time. So I need my resistor book. I don't have an 0805. I do have an 0805. 800 ohm. Let's just see how close we can get to that. I've got these all in organizational boxes. Those are mega ohms. That's definitely not going to do it. I spent all this time rearranging all of my 0805s, and what I really should have done is just gotten one of these books that are full of components instead. That would have been a much better organization. And maybe one day I will. I'll throw all these out. Here we go. 120, 220, 680, 820, or 750. Let's go with the higher resistance. Let's go for 820. Even though, actually, well, 750... we're between 1/4 and 1/8 of a watt. So 400 ohms is 1/4 watt. So let's go with 750 on that. That's barely gonna slow it down or speed it up or whatever. And we'll be nice and kind to all the rest of our electronics with it. Oh, there it is. Okay. I was like, where did it go? I don't see it anywhere. It's too small. All right, come on. So this like that, and then this will come in here. So let me get that soldered, just so we hold it in place. We'll solder it on this side because I still need to fit the transistor in there with it. Transistor. Things certainly will not be dissipating a lot of heat. The light stand is right in my way. It's where my arm is. Right-handed, lights for the right. Jeez. Okay, let's get the yellow wire in there so it's out of the way. This is the beauty of surface mount electronics. I've got my voltage source and my voltage, whatever, drain, I guess, sitting right next to each other. Now, by all means, I should have used MOSFETs for this. MOSFETs would have been easier for the microcontroller to truly trigger and blah, 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 blah. This is just what I had. The SN5551 or MBT5551, whatever it is. It's just what I had. I just had it on hand, so I'm using that. It's not the best for this application. It is actually meant for this type of application, although not specifically to enable charging. We will just use it as that. And I could have come up with a circuit to make this voltage controlled so that at a certain voltage, the second transistor would be set off. We don't really know where that voltage is going to be, and it's potential that we'll blow these up, so we're just going to have fun with it. We'll charge it with one initially and just see what it does. And instead of leaving it up to circuit elements, I'm going to do it with a microcontroller. It is just as valid to figure out like a voltage divider that'll get you to that 1 volt saturation when the power is at a certain voltage. So you'd basically say, all right, when this reaches 60 volts, this needs to be at 1 volt, and then I need to keep it from overvolting when it charges up to 100. What would that be like? Hold on a second. If we'll just use a calculator for this. So our voltage divider calculator, our input voltage is, let's say, at 30 volts, and then I'm going to need the output to equal, and I guess I get to choose. Do 800, 800. And so that takes us to 15, but I need it to be 2000. That still takes us to 21 volts. It's going to have to be like 300K to take us down to 29. Okay, so that's just lowering the current if I raise that. But we're asymptotically approaching a number. Okay, so maybe a voltage divider wouldn't exactly be the right thing. I don't know. Plus, it would probably get hot. Okay, so voltage in, voltage out. We got it all set up there. We've got our bleed resistor, which is 750 ohms, 751. 7.5 with a 1 after it. That may need to be bumped upwards in order to fit our next transistor here, which will bypass this one. That, or I can put wires to come down here. Maybe that's what I'll do. So this is a fixed system at this point, and it is exactly what we want to test first. So I really don't need to add more at this point. I don't need to add that other transistor, but I guess I'll put it in just because. The breakdown voltage is a lot higher than what we will be putting through this, so I think we're pretty good to go on that. And it'll just inform me of what I need to put where, and then we'll get the low voltage stuff in here too. So that essentially needs to go across these two. It would be so much easier if I did put this on the other side of the board, but I don't want to do that. I don't want to do that. I don't want to. I guess I'll just have to bridge it like this. Seems kind of silly, doesn't it? Because I can't really kick that far enough out of the way because there's all this garbage up here. Sand down. Put this thing on the belt sander and sand it down. I don't know where the silicon is in it, and it's probably a very, very tiny thing in like right here. So sometimes you can get away with that stuff. It's kind of weird with electronics like that. I hear high voltage caps. If these pop off, I am screwed, because you can think of like the amount of energy that an exploding capacitor releases. A shotgun shell sized capacitor gives off the energy of a shotgun shell, and these are like 20 millimeters. These are 20 mics that are sitting here on my desk. So I really don't want these to go off. Just, you know, one of those, it's just the weird thing about me is I don't like it when capacitors go thermonuclear in my shop. Just one of my weird quirks as a streamer. Plus, I don't have spares for these caps. Yeah, that's a good point. Only does it once. I don't have spares. Why did the whole thing just... It's like the solder's going under the pin. I'm just not soldering down the pin. I'm having terrible luck here. Well, here's what I can do. I can put this to the side for now. Did you just solder in? No. Okay. What the... It's soldering to everything but what I want it to. You just get away. Go away. I'll do the bridging of the pins. So that's these two. Wait a minute. Which ones do I bridge? Oh, I'm going... Yeah, those two. Okay, yeah, so it is these two. These two get bridged. So I'll just get any old scrap of wire sitting on the desk. Any old scrap of wire? Okay, here we go. Found one. Once I bridge them, they'll have something underneath. This is a very interesting soldering technique. It is something that I learned when working at the FBI's Technology Center, using wire wrapping wire as your traces. Yeah, it's like it did everything except what I wanted it to do. It was really, really weird. But I don't like using this technique on this specific perforated prototyping board. I just happen to have a lot of this type of board because it was cheap and easy to find and easy to order. I need to find the stuff with square pads that doesn't have anything on the underside. This has something on the underside, which is what we're sort of taking advantage of here, but the test circuits that I build on the square stuff come out a little bit better, and then you don't have to worry about placing them down on your bench because all the insulated stuff is underneath the board. And so there's no like circuit elements under there. I assume you could probably build stuff pretty compact on this stuff. I mean, any perforated prototyping style board it's never going to look perfect. It's never going to look nice necessarily. This is always going to be a bit of a sloppy procedure that I'm doing right now. You learn to embrace it though. That looks like a cold joint. We'll come back to it. It looks very cold. You can see the dark line under the wire, which makes it not look like it's exactly soldered. It's a thing you learn to look for when you build circuits. Things that make you go, hmm. This is upside down. That means the pins won't be going to the right spots. So if I flip it, and then collector is this side. See, now all the solder's up here. I can probably get a good solder joint going. Although it is pushing the component up, so that might be another problem. Oh yeah, I mean, there's no point in taking this to the next stage, which is a PCB. I do not need a PCB for this. This will work as a prototyping board, and when I'm done, I'll still have my Nixie power supply and all that stuff. If I did do a PCB with this, I would be modeling some of these daughter boards in 3D, which is, it can be kind of an annoying and time-consuming process. I really want this to be just twisted a little so I could get a resistor here. I think I could still actually get a resistor there. I think we're okay. My solder, can I have it back? Thank you. I don't know if that's like floating over the board or what. What have I done? What have I done? I guess it's okay. Not the happiest transistor I've ever soldered. That MOSFET or voltage regulator setup is so good. I've never seen someone use that wire connector thingy like that. Oh, really? I mean, it's just, I was just thinking like, the TIP 122 blew up in the last one we did, right? So why don't I attach it with something temporary? So these work. Push terminals could have worked. I don't know. I mean, I got it set up like this so that if it blows up, that means we'll be blowing up. Well, that means that I need to find a bigger FET than the TIP 122. TIP 122 is pretty strong, though. I think it should be okay. All right, so we need two 1 kilo ohm resistors, which I have in a bin right here. So I've got the 10s and the 1s in a separate bin because I use them so much. We're using 1 kilo ohm resistors. I've seen people use smaller resistors with these transistors. I hope that we are not underdoing it with the 1K, but I don't think we are. I think we should have it pop off pretty well with our setup. I don't use electrical tape. I hate it, in fact. The only good thing that electrical tape does is protecting things from the environment. The tape that is on this thing is called Kapton tape. K-A-P-T-O-N. Kapton. And it is a high temperature, low, what do you call it? I don't know, low something or other. It doesn't leave behind stuff. And it's light. And they actually use it in like satellites and stuff. There's a bunch of it on Mars. Because I saw a whole wire loom that was wrapped in Kapton tape. Yeah, it's very useful for a lot of things. It's not useful for some things, though. Why? You see, with the square pads, without having a via, a plated through via, the square pads will end up allowing me to have a little bubble of solder. And so these don't, because all that becomes a bubble below the solder thing. So here we have a big bubble of solder sitting underneath the board doing nothing. There, that looks more soldered now. Okay, there we go. That's cleaner. Cleaner. Let's get this one in. And we can figure out where the wires are going. One of them is going to have to come in over on this side if we're going to keep this area clear. It's unfortunate that I don't have any... I guess I could have moved this 90 degrees. We'll have to keep that in mind for next time. Move it 90 degrees, and then all my low voltage stuff is over here. All high voltage stuff is over here. That would have been the better way to do it, I realize now. Do I take the time to make this in the proper orientation? I think I do. Because this is all small parts. I can undo this part of the board very quickly. We're going to turn this whole thing 90 degrees. Yeah, I'll appreciate it later. All right. Well, here we go. Here we go. You guys get to deal with me being a weirdo with this kind of stuff. And that way our low voltage and high voltage stuff stays delightfully separate. Getting the transistors out is going to be kind of a chore. I can do it though. My computer's fan is like spooling up and down behind me. I think it says the temperature in here fluctuates. The old people in the house turn the heat way up when they're slightly uncomfortable. They're like, man, it's not getting to 70 degrees fast enough. I better turn it up to 75, which is not what you're supposed to do. It's not what you're supposed to do. The heat already works at its maximum speed, but they got to do things their way. Can't retrain them. And then I end up down here in the insulated shop, sweltering. Okay, so let's just get the solder out of there. Let's go to the other layer. Go to the bottom and get off of the soldering iron. I don't want to burn you. Nah. And it sticks to the tweezers. Just a chill Thursday soldering stream, huh? I don't think the solder sucker is going to be too useful for this. Maybe I'll use braid. Braid's expensive though. Braid is that game from that pretentious game maker where you reverse time. I remember when the Braid came out, we were jazzed about it. We were like, look at this indie game that does some really cool stuff. You can like reverse time. And you finish the game and you're like, oh no, I wasn't a good guy. Sorry, spoilers for like a 20-year-old game. Finally found single-sided square PCB on Ollie. Interesting. As an HVAC tech, it is extremely annoying having to try to explain to someone that turning the heat up does not make the temperature from the vent hotter. I feel you on a cellular level. I relate to that so well. God. It kills me though, because the old people don't have a lot of circulation, so. But then I'm also talking about somebody who wears sandals in the middle of the winter. I'm like, you don't have socks on. You're not cold. You're just not properly dressed. It's a losing battle. Airplane crashing outside. For some reason, we're close enough on some kind of a flight path. I mean, there's a lot of flight paths around this area of Philadelphia because there's the international airport. There's probably also a couple smaller like airfields in the area, but we get these airplanes periodically that are small craft that sound like they're dive bombing the place, but I think they're just doing like a final altitude change before landing. That or it's just the Doppler effect. They give you the lost dog head tilt like you're speaking French. Oh, that's when they're just straight up not listening to you. I got a lot of that when I was trying to educate on the regimen of feeding that the dog should have, which should have been open feeding, and they just wouldn't understand it. They just couldn't. Like it was talking to a brick wall. So I lost that battle. Not by virtue of fighting passionately to keep my dog healthy. She's now more than 5 pounds overweight. Not excited about that. Corgis are supposed to be around 30 pounds. She's around 40, plus 5. Not good. Ah! Who said idea? Oh, you said ideal. You blasted my eye sockets out of the back of my head. How do you do that if they're a socket? It's defined by its absence. That doesn't make any sense, Father. You're not making any sense. All right, so the bleed resistor is going to be up here. Or maybe here? An adorable chonker. She's not supposed to be a chonker. As great as it is posting all the pictures and stuff of her on Discord, and as cute as she is, I really want her to have a long, healthy life and to feel good. And to do that, you cannot weigh 45 pounds as a dog. All right, so this is my first row. Before these are essentially have a post on them, so they're grounded. So this row will be for wires to go in. Here is the bleed resistor in board because it's higher voltage. So that means that our source comes from over here and goes down here. I could move this around and go this way, but I want to keep the wires kind of packed onto the board. So we're going to have the yellow wire go in right here, and then the blue wire will be actually here because it goes through that last transistor. They're flexi. Oh, I remember those. Who is it? Adafruit had those as well. Yeah, they're like little flexi prototyping boards with square holes. It's for some reason the stuff that I like is hard to find, and it's probably because I got used to using them, and the FBI probably ordered them from DigiKey, and so they paid full price, your tax dollars at work. But they were really nice to use for this kind of thing. This kind of thingy thing. Somebody found them previously in Credamike. I don't know who found them, but it was, you know, the ancient streams. Somebody had found them and linked me to it. And people think that they can find this stuff that I know that you can't find. Sometimes they'll like challenge me. They'll get like mad at me and be like, "Of course I can find you Captain tape that has a copper cladding on the front. I can find you that." And they'll link me to the same tapes that I keep finding over and over again. Oh, I just ruined that. Ruined! You ruined him. It's because these holes, the solder's not pooling on top, and it just falls below, and it leaves me with a component that's not even attached. There we go. Okay. I'll stop freaking out for just a second to relay that information. So the collector, so it goes voltage source, collector, and so the collector is the 1 pin. Incisor. What I'll do is I'll actually offset the other stuff. So the collector here goes up. Just spread the circuit out so that you can see what it does at a glance. So that's base, that's collector emitter here. And this is the bypass transistor. Now I'm going to turn it a little bit more. Hello? There's so much stuff to burn in this area that I got to be kind of careful. Why am I not getting heat into here? What's going on? Iron's off. Damn it! It thinks I'm soldering in bed at night and that I've fallen asleep. Alright, that's super ugly, but it'll be okay. It'll gonna be okay. And that's fairly hard to get to, but I think we'll be okay. Yeah, I am much happier with myself having redone this portion because it'll go in much cleaner. You know, the components aren't clean anymore. Would you just flip over? Oh my God, I am going to flip the fuck out. I am going to go. Okay, we got it. We got it. There we go. All right. This can sometimes be very, very annoying. That's why I've perfected that maneuver where you flip the tweezers in your hand in order to flip the component over, because I've been struggling like that for like 10 minutes at a time. When you've got a lot of components, you can just kind of poke your finger on them, and then your finger oils are going to pick them up, and then you release them, and some of them will fall up right side up. But when you have one component and you need to flip it over, really limited options. And so this maneuver here, I'll show you guys, I'll get it up close, is something that you will want to learn if you do a lot of surface mount hand soldering. I get real close in, even though the light's in the way and my The camera rig is letting go. Okay, so you've got the component pinched with just a tiny little bit of pressure, right? Tiny little bit of, we need to focus better, hold on. Just a tiny little bit of pressure, right? You want your tweezers to be easy to pinch in so you're not fighting them too much to grip your component. My hand is cramping a little bit right now because I've held it still for so long. So you're holding your component and you need to flip it 180 degrees. So I move my middle finger underneath the one arm that was previously held by my thumb. My index finger stays on the other side until it can hand it off to my thumb, and then my middle finger tilts back until I can get the middle finger on the other side, and there you go. That's a 180 degree tilt. And it allows you to get to, or to put the component down right side up. Ta-da! Although these are annoying because that tilted backwards in my grip, so I don't know which side is vertical. Nope, it's the wrong side. Okay, flip it over. See that maneuver? Just did it second nature. And then you put the component back down to where it tilts on its face again. God damn it. That's so annoying. So the same over here. Oh, so we need to flip this way. Collector, emitter, base, just like that. The finger ballet. It's pretty good. That was a 1,000 RPM at least. What are you talking about? Oh, lift it, drop it, let chance do the work. I have a statistical probability of this going right. Oh, damn it. These components are covered in flux. That's one of the problems here. It's kind of hard to see what we're doing. At least for me, I don't know. You guys maybe, you might have me on a different device, or you might have your face in the monitor, which I don't. Monitor's a couple feet from my face. But it's, the shadows are very, very dark. Makes it kind of hard to see. What? Wait, no, that's the wrong way. It's this way. Shit. It just flipped over. Would you? Oh my God. It's like concentrated military grade frustratium. And everything is covered in flux too, so it's just that much more frustrating. Okay, so like this. Just a stack of transistors. I would like that to be a little flatter, like its buddy is. That's pretty good. 3 transistors in a trench coat. That's what a Darlington array is. It's 2 transistors in a trench coat. That's what this is. Oh yeah, that's much better. Where's my other resistor? Oh, don't you know? Here it is. Here it is, right here. Don't get nervous, I'm watching. It's a little creepy. It kind of makes me nervous. I think something's broken in my brain. I don't really get nervous. No, I do. I actually get very nervous. I get the nerves. I just wasn't that nervous hooking up an IED designed device that I hand built to 60 pounds of commercial explosives. I was like, something's wrong with me. Like, And not like in a Hurt Locker way where it's like, all right, just don't get a thrill out of the job anymore. Maybe it was just the engineer brain taking over and going, you know exactly how this thing works. We're fine. All right, so this is power out to the coil, or to the capacitors. So this is going here. It has to avoid all of these pins here because those are off limits. And so we go to the top of the thing here with this one. And I guess we could shorten this up a little bit. This thing does not have that coil whine of a typical high voltage circuit because we've got sort of a Nixie power supply running it. So it's not going to go ree and then ka-clunk when it pops off. But it will go ka-clunk when it pops off. I'm about to pop off. All right, let's get this in there. Middle of a windstorm, huh? Been a little windy here lately, just not windstormy. We are building a circuit. It's a high voltage circuit. It is designed to charge through a current limiting resistor our capacitors, because the last time we tried, we blew up a bunch of transistors. So instead of blowing them up, we are going to put them through a current limiting resistor that'll keep that high current coming off of the capacitor of the 100-volt power supply from blowing up all our stuff. And then we will bypass the capacitor so that it charges quickly again. We could just make the current limiting resistor charge it quickly. This is more fun and involved and weird. It's something that I haven't done before, is have a charge pump or a fixed current detachable charger with a limiting resistor that's bypassable. And you know, I've seen this circuit done in using a transistor, like using a voltage divider on the transistor, and that way when it gets up to a certain amount of volts, it'll then kick it up into high gear, because it will have shunted just long enough, or unshunted, limited, and then it shunts the limiting resistor, and that gives you the full power again, so that everything is settled in and you're not hammering away at high sources stuff. Can't put words together because I don't know all the power terminology that I need to. So anyway, what this is doing is it is a charging circuit that is detachable from the capacitors. So when it is attached to the capacitors, it will charge through a current limiting resistor until I activate the transistor, and then it will bypass that, essentially working as a short across the resistor. You mean the one with the heat sink with the bolt hole? Used to get a strip of anything metal, with few exceptions, few metal types, with a piece of jump scrap metal on it. What? What are you talking about? Oh, as like a heat sink? We're not going to need a heat sink for this, I don't think. It's such a quick activation. It is very high current, so there is the potential for it to get warm. But in our usage, when we had this on the solderless breadboard, because you know that's how you build stuff. You start with a solderless breadboard because you can easily swap components around. So we started with the solderless breadboard, like we should, and it worked really well. Things got kind of warm, but it worked really well. So. Okay, so D3 and D4 are these two, and so I am going to, I guess, we'll do a little bit of circuit sewing. So D4 and, actually wait, this is D1 and D4, that's weird. D3 to 3 goes this way, and it is actually the activator of the power supply. But when this is deactivated, when I shut down this power supply, there's still 9 volts on the line, so I had to put that second transistor in there to really cut it off. So D1, I guess, will be our, whatever this one is, yeah. So we'll come in over here. Well, cumin over here, sorry. Gotta say the spices right. Otherwise, there's madness. I guess I could sew it in. I could come over and go right, and then just go through this. And the other one will go on the row next to it. Up here, that's a little close to the high voltage, so I'm going to give that I'll give that a little breathing room. Yeah, that'll make this just a little cleaner. Just a little. Just a little. Oh, wrong row. I hope in the future to own one. Are you talking about this thing? Oh, what you created with a 3D printer was a great example of what could be done with a 3D printer. Yeah, that's the most prominent use case of the 3D printer since I got it, is as a machine to magically create replacement parts that are not available to purchase. It's really, really good for doing that kind of stuff. This is like really sloppy and I don't like it. That's all right, I'll live with it. So that goes there. And then this one, the old one, the new one is D4. So D4 goes there, and then D1 goes to the one above, except that might not reach. So I don't know what I should do. Well, okay, let's just do it, and we'll replace it if we need to. So let's just go down here. And it's really where 3D printers shine, is I need new thing, and it doesn't need to be exactly like the old thing. I did this with the washing machine, and I did it off air, which I kind of regret. But getting the initial shots of the washing machine would have been difficult to do. I could have taken a couple videos on my phone, I guess, and showed you guys. But with the washing machine, there was a roller that allows the sort of dish tray thing to go in and out of the machine. The roller was on an axle, which was fine, but then there was a pin in the axle that was a pressure fit sort of dealio, and the pressure fit sort of dealio popped out. And so what would happen is the wheel would just fall off of the axle and roll away. So something that just went inside of that, and it was a perfect use case. I used PETG, which is a bit of a hotter filament. It's also extremely widely available, but it was able to survive the heat cycling of the washing machine, the dishwashing machine. So yeah, I just designed a pin, printed it, and it worked perfectly. It did just the right job on it, and it was just a prime example of exactly the usefulness of a 3D printer. And nowadays, the 3D printers that you can buy are like pre-configured. You could literally do exactly it. You could do it exactly the way I did, which is where you figure out what the shape is, you make the solid, you put it in a slicer, and you say, hey, 3D printer, I would like this object to be on your bed in 20 minutes. And it goes, okie dokie, and then it just does it. That's sort of the grade of 3D printer that we have nowadays. Which makes you wonder why 2D printing is still so fucked up. Why can't you print something in 2 dimensions? We got 3 on lockdown. All right, those 2 down there like this. I think they're a little too long. And then we need to do the 2 bridges over to the bleed resistor. The current limiting, I should say, not bleed. We ain't bleeding. I should have made those a little shorter, huh? Well, low margins on this. I'll tilt them to the side. Where are my tweezers? Oh, they're there. Almost lost them. Go. Oh, we need to hold it down while everything turns into soup. It all turns into soup. Wait for the 3D printing companies to become giants. Bamboo seems to be sort of flirting with becoming HP. Don't you have to use their spools or something? It's a very HP-like move. I mean, you know, 2D printers didn't sort of come from a hobby movement. So luckily we'll always have that if these 3D printing companies decide to like act like their 2D counterparts. we still have all the DIY stuff. I guess if that were the origin of two-dimensional printing, then we totally could have still had a DIY market for such things. Star Trek or Star Wars or both? Trekkie, because it's science fiction. Star Wars was science fantasy, and there was more Trek traditionally to watch. It's just the show that I loved. I didn't dislike Star Wars. They're not mutually exclusive, right? I didn't dislike Star Wars. I just didn't make it as much of my personality as a little kid. But, you know, TNG was coming out when I was a little kid, so it's like, how could you not like Star Trek when TNG was the show, man? But then Star Trek became action slop, so what do we got? We don't got anything anymore. Expanse was kind of fun for a bit. Where am I attaching this to? Forward on the... Oh, does that one go all the way over? It goes 1 over. Does it need to go 2? Yeah, it needs to go 2. So I need this, this, and this. Space soap opera. Not entirely. There's just always that science element to it. At least back in the day. Now it's... I don't even know. Although, you know what? Strange New Worlds, I have not fully... I watched, I think, what was out. I haven't seen any... If there's like a new season of Strange New Worlds, I haven't watched it. But from what I saw, it looked okay. And then the Lower Decks being kind of a love letter to the TNG era Trek, I loved. But, you know, the Picard show and stuff like that was pretty bad. Pretty bad. I don't know. Orville was a nice little Star Trek love letter as well. They did a pretty decent job telling a story. We tried to get one of our other friends into Trek, and because me and my one buddy are like pretty big Trekkies, at least in terms of like knowing the show and watching a lot of it. We don't go to cons or anything like that, but we tried to get another one of our friends into it, and we basically had to tell him, like, look, you gotta see it as like a theater play. It's not incredibly realistic. He was like, nah, I like Stargate. All right. I tried to get into Stargate several times on the behest of most of chat telling me to watch it. It's good. Watch it. It's good. I tried. I gave it my all. I tried watching it. I didn't make it through the first season, which I hear, if you make it through the first season, it gets real good. But I just didn't. Same with Babylon 5. I can't get through like the first episode, but I hear it gets good. But I don't know. I can't do it. It's me thing. It's not a you thing. Okay, so those are all connected up. We got our bleed resistor that's sitting over here in sort of high voltage land. It's actually here. And then we've got our 2 transistors. So this is our fixed current limiting resistor. We've got 1 transistor across it in order to bypass it if we need to. That one is connected to D4. D1 is connected to the cutoff transistor that will remove the charging portion of the circuit from the ballast part of the circuit. Babylon 5 is harsh, no one catches a break. That's what Expanse felt like with me. I was getting like fucking anxiety from Expanse because everything was so fucking hardcore in space, and people are like blowing up and everything is going crazy, and everyone's one step away from just fucking eating shit. It was nuts. Man. And then I watched Farscape, which I've seen several times. Watching through Farscape, everyone is nasty. Everyone is dirty and nasty, and the ship is gross, and everyone is nasty to each other. It's I don't know if it's great, but it certainly grates on you if you watch it as a marathon. You ever try Firefly? I loved Firefly back in the day, but if you go revisit it, it's full of that slightly too snappy Joss Whedon dialogue. Everyone's just a little bit too sharp. Everybody has a dictionary in their cabin. But it was a fun show at the time, which Fox wasn't so weird about funding these shows. All right, so now we get to put 12 volts into this thing. Actually, before we do, I need to grab the code and update it, and then we'll power it up without the power supply on. Yeah, let's move this. Oh, Babylon 5, B5 was kind of awful on the outset, but it became really great the more I watched it. Kind of had to, because my other younger son loves it. It's really worth the time. Oh man, that's time and time again. That's what people say. They keep saying it and saying it. You press play and it's like not even the StarCraft cutscenes. Those looked better than Babylon 5. The StarCraft cutscenes. It's very hard to stomach. I'm not, I'm fine with shit graphics in my games, but when it's on like a TV show, it's. I'll one day I'll have to sit down and really be like, all right, I'm going to watch this. But until then, my opinion of it is I'm not allowed to have an opinion of it because I haven't technically watched it. It's tough to break through the surface on some of those shows. I missed Orville and Lower Decks. I mean, I would just like to see them because I have not yet. They're good. They're good. I really appreciate them very much. And I know people were really reluctant about Lower Decks. They said, the Cal Arts style comedy show in Star Trek. But when you watch it, you can tell the people writing it really had a love for the TNG era kind of Star Trek stuff. It's like packed with little quippy references and stuff. Don't expect it to be anything that it's not, but it actually does a pretty good job of telling a story in the universe. And then also breaking the fourth wall for comedy, of course, or third and a half wall. I don't know. It breaks its own universe's walls sometimes. All right, yeah, dead crewman reanimated into tech-hungry beasts by Borg microbes. Wes accidentally calls Picard mom in front of the entire bridge. There's a juxtaposition of plots that sometimes are a little goofy. A lot of it was because of Gene Roddenberry keeping the writing in the quote-unquote Gene Roddenberry box, which means that, we've evolved past interpersonal conflict on our ship, and the writers are like, but that's where stories are. How do we write stories without that? Charge pin, solenoid pin, enable pin, bypass. 4 inputs to do just about the same thing to everything else, but we've got to coordinate these. So we do the business of setting up serial for debugging, setting up the Wi-Fi connection, setting up the Arduino over-the-air uploads. We set up all the pins to be what they are, and we actually need to go into that one now. So set up pins. I like using my functions in programming, in my functional function programming. Function-based programming looks inside functions. I like using these in order to organize things, and that's like the most bland, stupid statement you could ever make because it's just basically why programming like this exists. But I use it to organize things so that when I come through and I read setup or loop, I am reading the steps of the microcontroller doing the business of microcontrolling. So instead of having if statements and for statements and all kinds of sloppy programming inside of your setup and loop, I just put a bunch of functions. Now, in a simpler program, I will of course break protocol with that, but this is doing enough complicated tasks that need to sort of work in concert with one another, that having the functions in there, really good, because we can get through and I can just say, this is what it's doing here. So set up pins. Set up pins is right here. We do pin mode, and then we set our initial high or low. The initial high or low set is sort of an offshoot of older microcontroller programming, but since we're dealing with active low and active high being mixed together, we want, on initial setup, we want the microcontroller to turn off the 100 volts. So we got to be careful with that and make sure that we are setting it high or low. And I'm saying high or low in here. Sometimes I'll do 1 and 0. Sometimes I'll do true and false just to mess with people, because all of those are valid as 1 and 0. You think of high, true, and 1 are all the same thing. It's the same thing. And in more hardcore microcontroller programming, instead of saying digital write, you would send 1s and 0s to a bank of pins. That's all this does in the background. It does it in a couple milliseconds. It's very fast, but you can actually take over those commands and get directly into the pin registers. That's if you have something that's so fast that your microcontroller is struggling. Picard wrestles with the ethical ramifications of altering a murderer's memory. Also, somebody pooped in the holodeck and now it's ruined. That's more of a Lower Decks. That's more of a Lower Decks style plot. But yeah, sometimes well, what was the B plot for the day in the life of Data? What was that one? Was there a B plot on that one? Sometimes the AB plots are not great. Riker is kidnapped by aliens and Wes has to do his laundry. Yeah, fine. It is like a stage show, and there's a very clear A and B plot, and mostly through TNG, there is just the hard reset at the end of everything. Although TNG got a little better with it, they had sort of threads of like larger plots that ran through more than, a season. Voyager was extremely guilty of just having the reset button at the end of every episode. So, oh no, they blew up the whole ship. Oh, there's another ship. It looks just like ours. It just never fails. Sounded to me like you said milliseconds. I've never heard anyone voice that before. Fun to contemplate. I don't know where I originally picked up on it. I hope it wasn't AVE, but I heard somebody say milliseconds, and I was like, done. That's part of my vernacular now. So I pass it on to you. You may take it as far as it goes. Okay, so we have a new pin. If I was really like one of the really just exhausting comment things, you would do enable pin like that on each one of these. But I think it's relatively clear what it's doing without me leaving 10,000 comments. That's like when you have a learn programming curriculum and you're looking through it and it like comments everything. Yeah, and Voyager had unlimited shuttles. I think they just had a shuttle replicator, and that's why they couldn't afford all the other replicator rations, because B'Elanna just stole them all and just duct taped them all together in this big heaving pile, and so they hit a big red button, and it goes, and then a new shuttlecraft is there. Really? Was it that many? The runabouts, wasn't there like a thing about the runabouts in Deep Space Nine? They started running out of like cities to name them after or something, or no, rivers to name them after. I remember Rubicon was one of them. Pin mode. This one is it was bypass. Did I just bypass? It should say pin after it. I need to put the thing that it is. So bypass pin. It's a long title, but hopefully it'll stick. Bypass pin output and pin mode, or no, digital write. Bypass pin low. So we're not bypassed. Yeah, the race shuttle. They actually they addressed that in Lower Decks. They had an episode dedicated to that. Crap, what was it called again? I remember Delta Flyer, that's what it was called. I know a lot about Star Trek. I've watched it a lot and I've read books about it. There's a book called the 50-year mission. Or is it the 25 year? It's like 2 books. Each of them deals with one era of Trek. So the TOS era and the movies, and then the TNG era all the way up until this was during the sort of the lull before Paramount decided to go all in on Star Trek again and make a bunch of really terrible series and then follow it up with a couple series that are actually okay. They didn't cover that era. It's all the old stuff. So it's basically a compilation of interviews with the actors and the writers and the directors, and there's a little bit of Gene Roddenberry in there too. It's pretty cool to read up on, but it's supposedly unabridged. I don't know if there's any controversies around the book or whatever, but I think it's a really good sort of behind the scenes of what was going on. I had the type of autism where I'd read the Star Trek encyclopedia for fun. Listen, somebody who suffers from hyperfocus, I get it. I get it. Um, all right, so we've set up the pin. We're ready to do stuff with the pin. This is all the business of setting up the ESP and some indicators, like to say that setup's done. We then check MQTT for a message, and then down here we're actually taking we're parsing the message out. And what I've done is I've given it a singular number. So what happens is I take that number as, I think it's, yeah, the parsing, I guess, takes the 2. Yeah, 2 numbers. The 2 numbers are parsed and turned into an int. We can get more complicated with that, but I'm just learning all these codes right now. So right now, I'm given it a number of milliseconds that it should trigger the tip 122 for. I don't have any other numbers coming into this thing. I could program it a little bit more extensively to have 3 numbers. I could have a bypass count. I could have a charge count, and then I could have a firing count. But I guess I've kind of put those into these delays. Charge time. So in this case, when we go to fire, and maybe we should make this a little bit more complicated in the future, but the TNG technical manual was fun. I don't know how these days, as an actual engineer, how I would take the technical manual. I might not like it. Vero board ordered from the UK. No. Yeah, that's a tough search. It's a very tough search. I'll have to try to do it on my own. I've got too much on my table, though. I'm going to reinvent all of my audio stuff this weekend. So I may not stream tomorrow. I might not be here tomorrow because I'll be tuning my audio, and I refuse to stream until my audio is like perfectly good. So I'll probably bring the mixer over to this table, sit down with a pair of good headphones, listen to somebody else's stream, and then compare recordings of my stream to that so that I can get all the volumes right, so I'm not clipping, so I'm not in danger of clipping, so everything works. It's been too long since I've done that, so. And then I won't have to use the insidious, hiccuping and burping. I hate that it happens so much with me, but I ate lunch before stream, and so my stomach is like not exactly super settled, and then I'm talking on top of it. I'm moving my diaphragm all over the place, so it's like all my food is like doing like the Matrix rave while I'm talking. But yeah, these M Audio plugins that I use, I want to get rid of these. They're good. These are good. These are great. But they're attached to OBS. So if I wanted to bring my voice somewhere else, can't do it. I may have one worse. I would ditch my high school typing class and read encyclopedias and the university dictionary, which was so big it was on a podium by itself, and to me was a gold mine. I did that with data sheets. I would do that with data sheets in high school. I would print out data sheets at the library, and I had a binder that was filled with them, and I'd read through them. I wasn't smart enough to really parse them properly, but that's what I used to do. All right, so the enable pin we have low, so we are not enabling our power supply. Why? Wait, huh? The charge pin goes high. This is why we love DigiKey, yeah. DigiKey is as much a parts supply store as it is an archive of old component datasheets. All datasheets all well and good, but as soon as they change their UI, or they could just die, and we would have no good source for them. So it's nice that DigiKey keeps all of the old datasheets for the stuff that they've had. And then most of the places that I've worked with, most of the technology that I've worked on, they just default order from DigiKey. So if I can't find a datasheet, it doesn't exist. Or like if I'm working with something, it's like, oh, they bought this from DigiKey. I know I can find it on that website. For the IED job, I had to do a lot of very crazy searching. We're talking like 4 to 5 pages into Google. And this was back when Google was useful, before they destroyed everything. This was only just when the sort of ranking stuff started to become a thing. So I was able to actually find good data 5 pages into Google. It was crazy. It was the early days of Google Images too, where you'd look up a product and you could go 16 pages into Google Images and find that product. Okay, I don't know why I'm doing the enable pin low here. And am I setting it low again? High. That could have been why this thing blew up. So I have two delays. I have charge time and I have deno. Let's redo the logic on this so that I know what's going on. So it's charge pin, and this should actually be 4,000 now. We're going to do 4 seconds of charging. Yeah, when you could click on the cached version of the page, that was really nice. I wish they still had that. Those were the days when Google was actually useful, and now it's all under the hood. We don't know what's going on, and it's trying to sell us stuff or get us to believe in some kind of its own agenda. We'll call it bipin. Bipin. For bypass pin. Maybe that can store in archive.org, which is a gargantuan. Yeah, it's the Wayback Machine. I actually used to watch that show. It's a Pinochle and whatever. Charge pin, solenoid pin, enable pin, and bypass pin. So charge pin is this. Charge pin is this. Bypass pin is this. Enable pin is here, and then the solenoid pin is that. So that triggers it. So it's I'm going to mark it down here so I can reference it more easily. So this is the bypass is D4. The enable pin is D3. The charge pin is D1. And then we're firing on D2. Okay, now I got that reference too. So when we pop off, we get the int for firing time. So the first thing that we do is charge. First thing we do is charge. All these pins should be set in their original settings. So actually, before we even do that, what I'm going to do is reset. So when we reset, we're going to want digital, right? We'll just reset all 4 of the pins, actually. So digital, right? I could make these one command, but charge pin. So the charging is going to be set low because we're not charging anything up. Digital, right? We don't have to necessarily reset them like this, but I think it's good for peace of mind. And the solenoid pin is also low because it's NPN. The enable pin, though, is actually high because it is a active low. And then the bypass is set low as well. Okay, and then take that all in and format our code so that we're not a rules violator. Oh, we're still inside of an if statement too. Dude, if there's a message on MQTT, we do the business firing. Fire the missiles. Charge. Charging. We do that by enabling the charge pin. The enable pin. And we set that low. And then we digital write. Should we have a settling time? Delay microseconds. 20. And then the charge pin, I need a better term for that one. High delay. It's charge time. CHG time. So we delay for the charge time. Then we digital write. Actually, we comment out this line. By pin high. Then we comment out another delay. Delay Q time, quick time. Then we digital write. End pin low, because we're done charging. We disable, actually we first charge pin low, so we're ready to fire. And then what's chat talking about over here? Love the old internet days when you can Boolean search and read stuff on depths of different sites before everybody knew they should have IT security. Oh, yeah, there's a term for that where you'd get rid of like the URL and stuff. You'd mess with the URL and you'd be able to see the FTP files sitting in the directory. There's a couple sites where you can still do that. Pretty cool stuff. That was always fun. Until I found some very private pictures on this one Airsmith's site. Somebody who did paintball stuff. I was like, oh no, I shouldn't have seen that. Digital write, charge pin low, enable pin low. So we've set the charging to be off, and then delay microseconds. I'll give it another 20. Paintball body artist. That would hurt like hell. So we put that delay in there, and I should actually probably space out the delays for the different things that it does. We'll put the delays out in their own little land. That way they're just a little bit more visible. All right, so the enable pin has gone low, so 100 volts should be present. We put the charge pin on, which means that it starts actually charging through our current limiting resistor. So we then wait for the whole thing to charge all the way up. This would be the bypass. We activate the bypass, and then we'd wait for the whole thing to charge up. But we're testing it without the bypass first, right? It's Arduino C++, we call it, because it's not quite C++, but it's also not quite C. Why is all of this audio getting through? What's going on here? Can you guys hear the fan in the background or something? There we go. There it almost got quiet. I need to work on my audio for sure. I'm seeing it right now that there's a lot of noise in here. And usually I'd solve this by lifting this up. This is where it should cut off. Yeah, it's a bad show. All right, anyway. I need like a microphone that's just on background noise. All right, so charge pins low, enable pins low. We disconnect. We make sure that all the electrons can get to where they need to go. I don't know if that needs to be a delay. It probably instantly cuts. But before we'll give it that delay there, and then we finally fire. And so what we're going to do is digital write the solenoid pin solpin, high, and then we delay for dunno, which is the variable that we just created that has the parsed number in it. And then everybody goes back to their original places. It's not being a chronicle audio file. It's I am broadcasting audio out to you guys, and I need it to be pleasant. I don't want it to be overproduced. I don't want it to be underproduced, raw, screechy noises. And I am working with a fan on me in sort of acoustically a decent area because there's a lot of stuff to absorb reflections of audio. So I owe it to my audience to have high class, high quality audio on my stream. And I do that with a microphone that can be gotten off of eBay for $150 instead of the typical podcast $400 Shure microphone that has a tiny little wire on it. So you wonder why all the audio cables have to be big, thick cables to run the audio, when in the Shure microphone they use this tiny little wire. Tiny little wire. Okay, so that is our triggering sequence. So that being said, I'm going to plug this thing in without the 100-volt power supply on it, and we will get our code onto this board. Where am I getting 12 volts from these days? I guess we're going to use this thing again. This janky POS barrel plug setup. And I'm pretty sure the stripe is the pin. That's how they normally are. I guess I'll use these clips too. Having a lot of like pass-offs of power, having the power go through like this clip and then that clip and then the other clip, it's generally not good, because you can have bottlenecks at those areas. And also complexity versus your lab setup. You want to keep things simple, keep it neat, so that you can figure out what's not working at ease. You know, you don't want to have a big, crazy bird's nest of wires. Sometimes that's necessary, but like on your breadboard, if you have a giant bird's nest of wires, you then are responsible for cleaning that up or parsing through that in order to find where an error might be. And I've had circuits where you push down on the bird's nest of wires and suddenly it starts working again. I don't like that. There comes a time when you're developing stuff, when you're breadboarding, where you have to stop and break everything down and put it all back together. No matter how simple the project is, that's usually a universal constant, is that at some point the whole setup just needs to be broken down and built more neatly so that you can figure out what the hell's going on. Okay, so everybody's connected. The only thing I need to do is put 12 volts over here. Now, this is an insulated surface, and I brushed all of the little pieces of wire out of the way. Hopefully, this whole setup works, but power supply is at 12 volts. Okay, that's ready to go. So I can plug that in here. I can give it 12 volts. We're not going to have any high voltage sitting on anyone. This thing should not move, and if it does, we got problems. There's 12 volts going to the Arduino. That LED should be turning on once it gets up into Wi-Fi. .151617 amp. 200 milliamps? What the hell? How is this thing pulling 250 milliamps? That capacitor does not look too happy with us. I'm going to go ahead and turn this off. And we're going to investigate that capacitor. That should not be getting that warm. That almost blew up. Oh, thank you for doing that, Short Lurker. Check with 3 different headphones and earbuds and don't hear any fan noise. That's the wonders of my frequency stuff. That capacitor is straight up having a bad day. Yeah, at some point, Shorts, I'm gonna bring the mixer over to this desk and go over the lav mics with the Rodecaster 2, so that I can get that working as my permanent microphone input for everything. Because enough is enough. What happened yesterday is I was rattled to my core because I put a lot of work into my audio stuff, And 2 people came in at exactly the same time and had the same commentary about not being able to hear my voice at all, which I don't appreciate very much, but it seems like things kind of walk back and forth on my Focusrite setup. If I can free up the Focusrite, I could potentially move the other Rodecaster, the old one, and then Julian will finally have his Focusrite input that he always wants. That's all he wants, is he wants the red box on the desk, and he plugs into the red box. He hates that mixer that I have, and I would love to sell it, but I'm really bad at selling stuff. But I found a video. I don't know, I think you have access to every room in the Discord. I've got the admin room where I can get away from the peanut gallery and do work. And I had a video that I found where the guy went through his lavalier microphone tuning, and it was much different than what I did. I just took the different bands and I moved them up and down while recording in OBS, and I figured out what sounded good. So this is what sounded good according to me noodling around with the settings in OBS. But if I do go back to like a parametric equalizer like this, I can actually control it a lot more tightly and really get rid of the muddiness of my voice. We can get out of here, and it won't sound overproduced. A fairly nice set of speakers. They're little bookshelf speakers, and they're capable of subwoofer input. And the sound sounds quality. Very happy with it overall. Video production is nice sound. Okay, well that's reassuring. Because yeah, I'll still go back and work on it, but yeah. Yeah, orientation is short. I know how to diagnose a bad cap. Were these getting hot yesterday? Or is it just something shorting out on the body of the cap? All right, so plus and minus. The AMS 1117. So let's take a look at that here. I don't get why the inrush was 250 milliamps. Maybe it was from that cap. AMS 1117. Yeah, so try to resist the urge to remote pilot your streamer. Found this on Ollie. It's not terribly cheap. But we saw it for a split second. Maybe it's not available in my country. Just a split second. All right, AM 8084. What? Wait, what? Huh? AMS 1117. There we go. Data chart. So, They never make it easy. Okay. We are the SOT223. So, ground is pin 1, V out is the middle pin, and V in is the side pin. So in this case, V in is this pin all the way over here. This one's V out, and this one's ground or adjust. So what do we have on the other side? Input, and then capacitor, and then 12 volts going to the PSU. Why is that? Why is there so much wire in there? V in, V out is on the middle pin. This goes where? It goes under here to... Yeah, that goes over to the power supply. The 100 volt. So that goes to the 100 volt. That is also V in. That is also 12 volts. It goes down to this leg of the capacitor, which is the plus leg of the cap. The cap is... how many volts? 50 volts. And then the positive lead... Sorry, that was the positive lead of the cap, and then it goes up to the voltage regulator there. This is our output. It looks like a cold weld. Let's just make sure that's really soldered. Oh, right, this is on the tab, so it actually is sucking all the heat out of my iron. Don't suck me, I need that. There we go. All right, so output also goes over here where it meets the other capacitor. That's this one. Why then would putting 12 volts positive into this thing, heat that up, unless my barrel plug is backwards. But the circuit was doing just fine. It might just be a bad capacitor, which is kind of an annoying area for us to have to remove a capacitor, but we could do it if we need to. I'm going to sneeze. All right, I survived. DC volts. Positive. Negative. Don't do that. Negative 12. These are backwards. This thing does not have reverse voltage protection because I assume that the user is not going to be an idiot. But lo and behold, they keep inventing better idiots. I should have put a diode in there. Although, you know, typically with a barrel plug, you don't really need to worry about reverse voltaging if you do things standard. But some companies flip the plus and the minus, so yeah. So that's what happened. The cap heated up because it was connected backwards. That we saw that happening with the big capacitors when I had those backwards. That was scary. If those got super hot, they could blow up. This one survived it because it's a 50 volt capacitor, but it's still heated up pretty significantly. I hopefully didn't damage it in any way. So I'm going to turn 12 volts back on. You're going to keep an eye on this little guy right here. Why are they getting warm? Strange. I'm hoping that the voltage regulator blocked any damage from hooking this thing up backwards, although I'm not seeing any current going into this thing. The regulator should be able to take reverse voltage, but there's nothing is happening over here. Are these connected properly? Everybody's connected. We should be getting 12 volts in here. Oh, what could have died from this? Or is it working perfectly fine? It doesn't really look like it is. If I hit reset on this, do I see blinking light? No. If I blew up another Arduino, I'm going to be mildly unhappy at myself, mostly. And you guys. I'm going to be pretty unhappy with you guys, too. You're not supposed to hook up the voltage backwards. It's kind of like one of the basics, you know? It's like a really simple thing that you can prevent is hooking everything up backwards. Don't tell me what to do. You guys are sitting in the presence of a seasoned troubleshooting expert. All of you, just take a seat. I know what I'm doing. So without the microcontroller lighting up, it seems like things are blued up. The first thing you would do in this scenario is do some voltage testing. Since we're not charging the big caps, it's a pretty low volt system. This is a very basic Arduino setup that you would have in your house. 12 volts in, nobody leaves. Bartertown. No, 12 volts in, and yeah, everybody is using 3 volts from the 12 volt line. So our input comes in over here. No, this is ground, and then this is output right here. So the regulator's blown up. Except if I check the input tab of the regulator, son of a bitch. Okay, the voltage regulator's blown up. I don't know how many of these I have. Actually, no, I ordered a bunch of them, so yeah. So input, no output. So that's our smoking gun, is this regulator right here. And I tried permanently turning it off and then somehow thought that it would turn on again. All right, so LM1117, we need to get another one. Turn off the 12 volt supply before I blow something else up. Son of a bitch. I should have put diodes on it. Diodes are kind of like just a nice thing to have because they'll keep that from happening, precisely what you just saw. Shocky. Look at all those. Got a lot of them. It's an 1117, which I have a bunch of. The 317 creates a lot of heat, like a lot of heat, and we don't really need that. 1117, 5 volts, 317, or no, it's the 317 that creates. This is the non-adjustable one, the one that was in this slot. I found it, and it was a 1.5 amp regulator, and it was perfect. It would have been perfect in every way because it had in ground out, which makes this setup a little bit easier to work with. And I put it down on the board without soldering it, and then I moved the board to try to put it on the vise, and it flipped out of my hand and hit my leg, and the voltage regulator hit my leg, and then it hit the ground, and then it was gone. It was just gone. I'm broken up about that one. Somewhere around here, 1117 3 volt. Got 2 more left in this package. I actually have a different layout one somewhere else, but these are the big boys, so they can dissipate a lot of heat. We had troubles with heat on this circuit because we were asking a lot out of it. Although now I don't think we'll have that much heat. It's just when this thing gets on Wi-Fi, it can draw like 250 milliamps. So this one is dead. There's a couple different techniques of getting these things out. I probably could clip the 3 leads. I don't know if my tools are going to be able to get in that deep. Maybe I can knife them. So let me unplug this thing from its connections. Luckily, there's no energy stored in here. We had a very dicey situation when we partially charged and the FET broke. There was no way to discharge it. I didn't put a discharge resistor across the leads of the cap. This thing can handle all the current we're ever going to need out of this thing. You're fine. You don't need to worry about me. Regulator probably might take a 0.5 amp, and then it would need potentially a heatsink. Yep. That's all we need. We're only powering the Arduino part of the circuit off of this thing. Thank you, Cheesy Popcorn. How you doing? I don't really know if this knife is going to be up to cutting these giant leads. I guess I could clip them with... but if I clip them, then it's going to push everything mechanically around, and it might break some stuff. That's why I'm hoping to just drop a knife on it, but I don't really think it's going to work out. That or I just bend the leads. I think that's what's going to end up happening. All right, so we'll get the big iron, we'll put it on this part, and then we'll bend up the regulator. Since it's broken, we don't have to worry about preserving leads. I keep dropping all of my stuff over here. Ah! my little iron holding board got stuck, and so as I was pulling it out, it just dropped all my irons all over the place. All right, so let's get this going. You can be rest assured that I know what I'm doing when it comes to these regulators. I am in control. I'm in my element. You are in my country. This is my country, my damn country. No, you're in my realm right now. This is you've sunken down to my level. I know what I'm doing here. That song from Monbazo. This is my country, my damn country. Such a weird song. All right, so we bend it up a little bit so it detaches from those holes. And now I can just, since I put knife marks into it, I think it'll probably follow those bends and just break off. There we go. So there's our voltage regulator. We'll just put that somewhere else. We killed it good. We could have saved it with a diode, and I could probably still save it with a diode if I could bother to put a diode on this, but I'm not. I'm going to continue to use it the way it is because things blowing up is more exciting. So let us remove the pins here, and since these are just surface mount, it'll just take heating it up and sweeping them off to the side and then ruining all that stuff. Perfect, wonderful, amazing. And now I got these pins somewhere around here that I haven't fully swept. I don't know where they are. They might have fallen in. Well, as long as things are relatively the same as they were, same as they ever were. This still looks cold welded. Get blasted with heat, fool. There you go. All I need to do is drop a regulator down, and I'm going to suck the solder out of these three. Maybe we'll use braid on that because it's a little bit more controllable on when I have just a loose board sitting on the desk. This is my country, my damn country. It's a xenophobic song, isn't it? So yeah, we want these three. 1, 2, 3. This one needs to be cleaned a little bit. There's still something in there. And I can use a different tip. I need a smaller tip to do this. I guess I'll go back to the one I was using, which is still hot. Ah! Wait there. Really what I wanted out of that soldering iron tip holder was for the ability to push the iron into it and then lift. Or no, it was press down and then pull back. And if you pull back on it, I wanted to grip the soldering iron so it pulls it out of the handle. And that way I could have had it attached to the base, and I would be able to push the soldering iron down and pull it away, and then push in and pull up in order to get a new tip on here. It depends on which one you order. That's why I got this out of the non-adjustable LM1117 bin and the one that said 3V3 on it. So this is specifically an LM1117 3-volt regulator. We just did all that. Yeah, we just did all that. I looked up the specific part number and we got it all together. This isn't a big mystery. This isn't something that needs any more input. We spent a significant amount of time when I was putting this thing together selecting a voltage regulator. I ended up going with 1117, something we've used for synthesizer stuff quite a bit. Yeah, putting this down in there is going to be difficult. I need to flatten the solder on all this stuff. So, I mean, I guess I could just heat it up from here, and that'll flatten it pretty significantly. I just tap in on these, solder is going to fall with gravity, and hopefully these will be mostly divots. Last second, come on, man. Just stay right there. That's all I want you to do. Don't move. There we go. I think that's kind of in. I don't know. Really could have given myself a bit of room here. Yeah, it's because this stuff is right here is sticking up. Hold on. Let's just remove all that solder and get that back in later. All this is because I plugged it in backwards by accident. I misinterpreted what pin was what on the barrel plug, and it bit me in the butt. So flip again, flip again. That right back in here. The light situation's kind of weird. I tried having like a ring light on the camera, but it just didn't, I didn't like it. This is slightly more dynamic, and I bring in that extra light, but I can't be asked to go reach for it right now because I'm in the middle of soldering. So the lighting is kind of harshly shadowed where it probably shouldn't be. Why is this not sitting flat? It's like all over the place, and it's really irritating me. Why is it doing this? Why are you like this? Okay, grab it flat, bring it over flat. Yet it popped up somehow. Why are you doing this? Like that. Here we go. Come on. Oh. This stuff's sticking up. That's what it was. There's a whole damn pin sitting there. That's what it was. I couldn't see it because of the shadows. There you go. Jeez, that was more annoying than it should have been. It's a little crooked, but I'm going to live with it because, yeah, because I don't want to mess with it more. So now I take big solder to get to these pins with this because I've got some connections over there. Really, it would probably be better to slide it in a little bit more. I think that's what I originally had. Yeah, it actually just moved itself a little bit there. Okay, and then let's get these two legs. I don't think I need to add much solder to them. Probably could solder them from the other end. But it's pretty tight in here. I don't want to melt the shrink wrap on the caps, so I've got to kind of come in from a really high angle. Come on. This is the same pin that the heat sink is on, so it takes a minute or two to get it flowing. All right, so those are done. How's this doing up here? I think that's making a connection there. That's all I needed to do to get to this. I'll try adding a bunch of solder right here, and it'll. What's going on? Why? Oh, my solder found one of the pins and went into it. Come on, there it goes. That little time it just went thump. You could see it kind of float in to where it needed to go. Just make sure that that's the case. Many such cases, yes. Okay, there we go. Yeah, so that's connected to the back. Okay, so new voltage regulator, who this? Let's get this thing up and running, and we'll see if I can't get this to take the new code. I guess I'll hook it up to all the accessories, even though we don't need them. That, this, and then this. Get the caps out of the way so I don't brush up against them. All right, so my diagnostic thermal imaging does not work when we have just soldered in the voltage regulator because it's one of the more heat-producing parts of the whole thing, and yeah, it's holding on to its heat pretty well. Our heat dissipation's not great, but I don't think we're going to be using the regulator out to its raggedy edge. The LM1117 can do up to 1 amp, I think, before it really starts to break a sweat, but you got to be able to dissipate that heat. This is just going into a couple pegs of the perforated prototyping board, and it's sort of relying on its own thing. I can add a big piece of wire if I really need to add some kind of a heat sink to this, but I don't think 250 milliamps, I don't even think it's going to reach that. So I think it'll be in a good place. It shouldn't get too hot. And then hopefully this thing will do everything that we made it do on the solderless breadboard, and then some. This is where we will be seeing an explosion when things kind of pop off, because we will bypass, well, we're not bypassing yet, but when we do bypass the current limiting resistor, this has the potential to send a lot of current down the line from this capacitor right here. Hopefully, in connecting it to the current limiting circuit early, this capacitor will reasonably bleed off its energy through that instead of hammering it right into our capacitor bank. But, you know, who knows? But this is sort of a method that I read about, and hopefully it's good. The first thing we're going to do is plug this in, get program running on the Arduino. Hopefully we didn't blow up the Arduino. So I guess what I'm going to do is, well, we'll have Arduino up. But what I'm going to do is power up the power supply, and we'll see what happens. I mean, I would like this to get a little cooler. It's still quite warm. It's kind of concerning that it's still quite warm. That all that heat that I put into it, although it is auto ranging the thermal imager, so. Nah, this is the voltage checks, it's fine. If it blows up, I got more. And it could already be dead. Power on. What is we drawing? We're not drawing anything. Power's on. We might have killed the Arduino. Any caps getting warmer than they should be? Well, the 1117 is quite warm without anything happening there. It's warm, it's not hot. Thermal cameras being overly dramatic. Let's do some voltage checks. Oh, and we have the LED on. Actually, we don't need to do voltage checks. It appears as though in under 70 milliamps, the Arduino has gotten onto Wi-Fi, if that LED is on. So we go over here and we look to see if we've got it in our port. And it seems that we do. We've got punch box with a higher IP address. So 158 was the board that we blew up. 160 is this thing right here. And so I can just hit upload. And our new code with all the whistles and bells in it maybe will eventually upload if the program can get its head about itself. There it goes, okay. Now, it could be possible that it's still not on Wi-Fi if there was something else wrong with the board, and those IP addresses are just kind of stuck in the Arduino IDE. I use an old Arduino IDE. I have to restart the IDE in order to get a listing of the proper IP addresses. It's just a bug in the code. But it appears to be uploading. It's not saying it hasn't connected. I don't know what indicator I'll have of when it's done. It just went to a new line and the LED turned off. Okay, so maybe it's done. And now this thing is getting back up on Wi-Fi. It's getting hyphy with it. There's the LED. So our electronic brain is churning away at Wi-Fi type stuff. So what I'm going to do is turn it off. The LM1117 is pushing about 70 milliamps, which is kind of a nominal amount. It is getting kind of hot. That is hot to the touch. So I'm a little worried about the 1117 sitting there doing its best. Maybe I can add a little piece of copper to it, and that'll be our heatsink. So let's unplug this, and let's get a little tiny piece of copper. I have shims somewhere back here. I have shims somewhere in here that I can use as a heatsink. Let me see. where did they go? They would be with the water cooling stuff, which is kind of dispersed throughout the whole shop. But I had, these were for, I mean, originally they were for burn the subs, so they were in here. Here's some old parts, including 2 water blocks. I'm not going to put a water block on the power supply. Don't be absurd. But here's a piece of copper that I can use. Looks like just an offcut of copper. It wasn't above 0.5. It was a current draw of about 70 milliamps. It was very low, but that is getting pretty hot. So I do just want to be kind to our LM1117 and allow it to dissipate some of its heat. This is actually a much larger piece of copper than I thought we were signing up for, but you know what? It's fine. Soften some of the edges here. Where's that heatsink that I put over here? I have a little heatsink that I solder on. You say 70 milliamps is practically nothing, but that thing was getting hot to the touch, so I'm not really going to mess around. I'm just going to put this thing vertically, or like right here. That's a little bit much, isn't it? Well, whatever. No, it wasn't 700. And it wouldn't cook immediately with 700 milliamps. I've seen these things go up to an amp. But there's also just nothing on the heat sinks right now, so I need to put something on there. You know, a piece of wire would probably be better than this. This is big and clunky, and it'll blow up as soon as something touches it. Yeah, this is not a good idea. All right, let's get just a big piece of wire, just a big old wire, just a big old wire like this, and just get a little off cut of this thing, and I could even stand up the ends for funsies. Yeah, 1 amp with a proper heatsink, yep. I kind of want that to be a soft edge here. The wire cutters, the Nipex, put a sharp point on the cut, and I don't want this thing to be a syringe. Okay, and then it was gone, and then it's just gone. It's not even worth recovering at this point. My sock is going to find that. It's going to end up in my foot. Jeez. I think my file's super dull. Huh. I guess I could also use the desoldering braid as a heatsink too. Actually, it might be better. Well, whatever. I'm going to keep going with my little devil horns here. I'm making just a pair of horns that'll be a heatsink for this regulator. Just an inverted stapler. The 1 amp rating was pretty unrealistic if you're trying to drop like 7 watts of heat at that point. That's with like a 7805, right? I thought the 1117 was a little better than that. Maybe it's not. Oh, that's the small solder. I want the big solder. I want big solder because I'm a big boy. Pre-tinning makes things so much easier. This is fairly old wire, so it's all oxidized and stuff. So getting a little bit of the rosin core from the solder on that, a little bit of that flux stuff helps move all the bad crud out and let your solder stick to it. And then I'm just going to put this right up against that. And that's a goal. Except it's all crooked. Hold on. My tweezers are not as good at gripping and controlling. This thing's probably toasty. This thing moving around on the desk is also very annoying. Stay still. Nope, 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 it's all wrong. Nope, not good enough. Damn it. There, a little bit more heat dissipation. It's got horns. It's a little stupid, but it'll dissipate the heat, so we'll be fine with that. Hmm. 30? I don't know. I thought this was 14. I think 14 was written on this. Okay, so now we've got heat dissipation on the LM1117. Don't know if we needed it. We have it anyway. I'm going to push these in a little bit like that so they don't get in the way of everything. Yeah, I want them to be pretty much straight up. Will be fine. I probably could have put a piece of desolder braid down on this and that would have also done it, but whatever. We're just being kind to our voltage regulators. So clean off the desk a little bit so I'm not stumbling to find things, and so if anything goes wrong, I don't blow up all of my tools. Just get things back to where they belong. Place for everything in its place. We're not doing 100 volts yet. We're not doing dead voltage regulators. This goes in the garbage. Not even putting it down on the desk so it doesn't end up back in something. I'm doing what I'm doing. Okay, so put the file away. Everything's clean and tidy. We can plug 12. We still haven't gotten past 12 volt time. Plug in the 12 volts, turn it on. 70 milliamps is what it's drawing initially. So it's not that much, but that voltage regulator was getting a little bit concerningly hot. It was hot to the touch, and I think it needs a slightly better way to dissipate all that heat. Those two little metal posts, while not doing much, they should help dissipate just a little bit more of that heat out. You can see what they're doing right now. They're getting quite warm, and this thing is really kind of hammering away at the power supply. I don't know why it's only saying 70 milliamps. I wonder if the draw is weird. Really, under 70 milliamps, this should be a little bit more tame. Well, it's doing what it's doing. So now I can introduce the 100 volt part. So the 100 volt power supply should be off in its initial thing. And then, yeah. Get this thing done. So let that, well, I don't know how much I need to let it cool. It just runs a little concerningly warm. So this is the danger part. This is adding a 100 volt power supply to the rest of the circuit. 100 volts only gets back this far on the circuit, but all of my 3.3 volt control stuff is very close to that 100 volt supply. It's sitting on the other side of a transistor, which is a little weird. I mean, diodes are pretty good at isolating things, but how much do you trust them? I guess I trust it enough to be in this circuit. We've got a flyback diode over here. We've got our 100 volt transistors right here doing both the bypass and the charging attachment, and then we've got our tip 122 sitting below everybody there. 100 volts comes in, it gets switched on to the capacitor bank, the massive capacitor bank, 4,500 microfarads, using this little guy right here. And the thing about this little guy right here is this thing can handle up to 600 milliamps at 160 volts. We are giving it 100 volts, and our current limiting resistor is limiting the current, believe it or not, to 125 millivolts. There we go. Omnifixo. I don't know what that is, 3D lasers, but good screen name. I like 3D lasers. Yeah, so we got stuff going on here. We'll see. Let's plug it in. I think most of my logic behind all this stuff is relatively sound, but if I made a mistake, it's going to be a big one. We'll see almost immediately, and usually we see it in the form of heat. So we are going to be locked in. I'm going to back out just a little bit. We're going to be locked in on the thermal imager, looking to see if elements of this suddenly get hot. If the capacitors suddenly get hot, then I will be very concerned. And right now, we are going to charge it for 4 seconds through the current limiting resistor. A lot can happen in 4 seconds. Let's just see. Ready? Okay. 3, 2, 1, power on, go. It's drawing a lot of current. That's 80 milliamps. But the LED's on. Everybody seems to be okay. Nobody's getting super hot. And remember, this happened last time. Everything came up to power, and it was totally fine. Everybody was happy. It looks like this is drawing 10 milliamps as like a default. So we've added 10 milliamps to the circuit. Now it's 90 milliamps is that's 20 milliamps actually being added. So it's 90 milliamps through our LM1117 at 12 volts. So moment of truth is putting an awe emote into chat. And then this thing is going to charge for 4 seconds. And I'm going to back up a little bit. Nothing happened. Nothing happened. Nothing happened. Oh, the one wire got... Huh? We're still drawing 90 milliamps. Why is the one wire very warm? That's a very warm wire. Why is that wire so warm? Oh, now everything's getting warm. Or it cooled off. Okay. I think maybe nothing happened. We don't have any volts on the caps. I'm going to put an awe mode in, and we're going to look at these wires and make sure they're not getting too hot. Let me do another one. Whoa! Lots of heat from these guys. And nothing happening on the high voltage. Huh. Maybe that transistor isn't so good after all. Perhaps I've misjudged you. No, we're not checking the voltage regulator output. If the voltage regulator had bad output, this thing would have been dead. So, does this damn circuit just not want to work? There might have been some fallacies in the calculations that I did for these transistors down here. So look on the thermals when I type in this emote. This might actually blow one of them up, but when I look at the thermals, do that, boom. All 3 elements are heating up for the 4 seconds, and then they cool down. And yet nothing is happening on the voltage regulator over the... Huh. I think I saw smoke. Oh no. Why can't I get this right? We got to find some some better switching elements, I think. Omnifixo is a helping hands type thing. See, I very much do not like helping hands. I think it's just the most annoying thing with this hobby. And everybody uses them, everybody loves them, that's fine, but they scratch your boards and they don't hold things properly, and I generally don't use it. If I were to really want to solder to this board and have it stable, boom, piece of Captain tape right across the whole goddamn thing. What I'll use alternatively is a miniature precision machine vise. This has enough heft to it, and the only reason I'm using something so precise is that it was in an estate sale machine shop. So I found this thing, it was already in bad shape. I use it now permanently as my circuit board vise. This is a Palmgren. So this thing was like $600 new back when they bought it. It's probably worth the same these days. I don't know. This one is not worth anything because all of the preciseness is gone because it's corroded and it's, you know, been through the ringer. But this is what I clamp the boards down with. This board is a little too thick for this thing. So, and then I've got another like machinist project vise that I'll use for larger boards that I didn't feel like bringing over here today. And the other thing I have was sitting up here, but I don't see it no more. I have like one of those flat clampy thingies, and I have a piece of circuit board on it because I was soldering stuff on top of that. But I don't know what happened. Oh, there it is. There it is. This thing. I got this thing. So this is just one of those very simple spring circuit board holders. And we could probably use this today. It's just, this is light. It just moves all around the desk. All right. So anyway, we're not using the vise. Our circuit went kaput. Yeah, it wasn't so much, I think it was in a tool chest that my friends got. Yeah, it's, even though it's lost its precision, it still has good use here as a vise like that. Here's the circuit that I built. So we've got 100 volts here sitting on this. Now, we didn't see anything on the voltmeter down here, right? Voltmeter should probably have a different symbol to it, but that's the volt, Control Z. There we go. That's whatever. So anyway, that's the voltmeter. So this is where we should have seen the needle on the voltmeter go up, right? But it didn't do anything. We have an 800 ohm resistor and we have 100 volts. So we activated the 100 volts and then something weird happened where everybody went to crap. Could I have activated the wrong one? Let's take a look. I want to be careful of capacitors around here. Red wire goes to D4. The red wire is the bypass. Bypass pin is D4. We can tell where you got it thanks to the rust. That's not rust, it's just a little oxidation. So D1 is the charge pin. They're totally different pins. We shouldn't have been activating them independently of one another, and yet all of this thing got hot. And it looks like these are having a bad day. These are straight up having a bad day. We didn't even see anything charging through that resistor. It's just everybody got warm in this area. So maybe I need to find something a little bit more geared towards high voltage. Or, you know, towards 100 volts DC. And it's possible that I have something. It just seemed like these transistors, the 5551s, were perfectly suited for what we were doing with them. Something is happening that I didn't anticipate. So here's the NE5551, designed for general purpose high voltage amplifiers and gas discharge display drivers. So this thing, the collector emitter voltage is 160 volts. We're running it at 100. The collector base, 180. Emitter base, 6. The continuous current, 600 milliamps. That puts us well within specs. So I don't know what's going on with that. One of them should activate, but why were both of them getting hot? They both should not have gotten hot. I guess maybe they're just not meant for this type of application, but I thought that's exactly what you do. Let's see, it's a 2N5551. 2N555 circuit. It's not an adjustable voltage regulator. Do we have like a specific 2N5551 circuit? I guess this one is. That's coming through a capacitor and it's switching. There are multiple different LM1117s, and if I could show you the text on this one, it says 3v3 on it. There's a 3.3 right there over there in the corner, right on the right side. See 3.3 in the part number. Plus, this thing would have blown up if anything was unadjusted, and this thing is working perfectly, so it's fine. Okay, so anyway, moving on. The 5551, yeah, here's two of them almost in this ridiculously similar setup. Hammering away at a coil. Even though we're not going to have it hammering away at a coil, we just want it to enable our charging. That's the whole video on it. This is like the perfect transistor. Why you gotta be like this? GPIO 3.3 volts into a 10k ohm resistor, into the 5551, and then also into itself with 170 volts. This is what we were doing. Damn it. I don't understand. If I got the perfect application, I mean, I'm using a 1 kilo ohm resistor. Do I need to be using a 10K? This site cannot be reached. Wonderful. I'm working with my Nixie clock, IN14, and I'm stuck on the one problem. When I tried to dim my Nixie tube through the transistor on a cathode, everything works fine. 3.3 volts, 10K, 2N5551. Maybe we need to put 10 kilo ohm resistors on there. Unfortunately, I can't have a transistor to dim the Nixie tube because I'm using a Nixie controller, so I could put transistor only on the anode. Okay, this is a weird question. 551 is rated for 160 volts, using it on a 170 volt rail. Are you PWM dimming? Using PWM for dimming. General long life best practice is to double whatever ratings you're specifying. The output transistor, when it's on, is not saturated, and we don't care much if it has a few volts across it. So we can use the HFE value from the transistor datasheet. I'll assume the Nixie anode current is no more than 2 milliamps. Adjust accordingly if yours is different. If you use the MPSA42, which is an NPN, blah, 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 100K, possibly overcautious. This, by no means, should this have not worked. This is... I don't understand. Why isn't it working properly? Because like our circuit is that type of voltage circuit. We've got 100 volts going into this thing, and our 5551 is switching the high current or the high voltage onto the thing in order to get it to charge. I don't know why that wouldn't work. Hold on one sec. Let me do, where's my MS Paint? My MS Paint of comfort, my comfort zone here. E5551, the collector. Let's just check BCE on this and make sure that I didn't do a brain fart. Come on, down we go. Here we go. Pin 3. 3 is the collector. So, on the microscope, yeah, I got that right. Collector, emitter, base. It's all right there. Unless some connection isn't happening, but I don't think that should not be the case. Is the inrush just way too much for a 750 ohm resistor? Do I need to bump it up to a 1/4 watt? Because that's heating up, and then the other two are heating up, which is a little concerning. If I plug the power supply in again, you guys saw smoke though. It was getting hot enough probably to melt the flux. Oh, I've got a... No, that's 102, right? Is that a 103? No. Okay, so let's try putting 10Ks in there, because when we were asserting voltages on these things, I think I saw even these resistors were getting hot. So maybe if we bump it up to 10K, and that's a no-risk kind of thing, because it's high resistance. It'll isolate us out a little bit more. So here are 10Ks. They're stuck together because I spilled coffee on this bin. Just because I spilled coffee on it doesn't mean they're not good resistors. Anybody who works in electronics is probably cringing at that. But hey, when I solder these components on, I might get a little whiff of coffee. So it's totally worth it. That was a planned move. I planned that. That was intentional, and I meant it. Ooh, wow, it's definitely not going to be soldering those with this. Although I could, but I'm not going to. I'm going to get this one. That was disappointing. I don't know if switching out the resistors is really going to help us, because it really should activate one of those for 4 seconds. The coffee is probably making them more awake and therefore more accurate. That is a good assessment. I will take that and I'll believe it every day of the week because it feels good. You know, the right answer just feels good all the time. That's what you know. You don't need to like look into stuff. You just, whatever feels like it's right will get you there. Now, I don't know if I burnt these transistors. I don't know if I need to replace those as well. Don't know how sensitive these are. Although, what we saw from the circuit was the transistors getting hot consistently. When I sent it that emote, each time they were lighting up so on the thermals. So it's possible that the transistors are fine and that they were just doing some weird stuff because we super duper overactivated them. But that doesn't, I don't know, why would both of them get hot? Is the resistor getting hot enough for everybody? And why would the line going back to the Arduino get hot? This doesn't make any sense. When I hit this shit with 100 volts, it should still be isolating enough that it's not PNPing or anything like that. It shouldn't be like letting current out the other way. And maybe it does. Maybe that's a big deal. Although if it did, it would be exposing our Arduino to, wait, that's the wrong spot. It would be exposing our Arduino to like many volts. So it would potentially melt down our Arduino. The survival of the Arduino is telling in the whole grand scheme of things. Running it with the thing not connected, we did that. That's how we programmed it. And it was fine. And maybe I can activate the transistors without... What'll happen if I do that? There won't be 100 volts sitting on the top of it. Maybe that'll smooth things over a little bit. Like if we don't see it heat up, if I run it with the things on... Those should be sufficiently apart from one another. And then there's nothing else going on here that's like shorting anybody. No. This, and this. So this is 100 volts in on the top one there. So that's this one here. 100 volts in all the way out to the current limiting resistor and the transistor right here. It's definitely connected. Yeah. Should be anyway. Add a little solder in there. Just let it kind of melt down. Yeah, that's that. That one's not used. So switches through there. So we send current this way, and then it switches. So we're not activating that one. This comes down through the current limiting resistor, which is connected over to here. That's here and here. Connected over to here, where we've got these two mingling, and they're not touching this one. Nobody's over there. So this one, we send 3 volts. We're now going through a 10K resistor, and we activate the transistor, and then that allows, through this 750 ohm resistor, we charge, and that goes out here, and it connects to the red wire, which is also connected to the voltmeter and the capacitor bank. Now, what if I didn't connect the capacitor bank? Would we see 100 volts on that line? Would it be able to dissipate? It would go through the coil eventually. So, all right, let's try without the 100-volt power supply. We'll activate this, and then we can try it without the capacitor bank. So this is 12 volts. This is hot. Actually, it's not hot. I'm going to turn it off over there. Plug this in. Let's just watch everything as we power up. This is going to get warm again over here. This was just soldered. So it is, of course, already hot. We need to let it cool off for just a minute so that this can get cool, and then we can diagnose anything weird happening. Can you do some continuity checks to see if everything's connected as it should? Yeah, that's kind of boring, but if you guys will humor me, we can poke it a couple times just to make sure. It's a fairly simple circuit, so if I just do ohms. Ohms. Here, let's go. That. You can see me poking it. Yeah, they're doing the yard right now, so there's a lot of motion detected here and there. D4 to this guy. 1 ohm. This will be 10K. D1 to here. 10K. I've got oxidation. The hovercraft races are going on outside right now, so there's going to be some commotion. 100 volts to 100 volt source, correct. 100 volts to ground, bunch of ohms. Bottom of bypass only connects to the bottom of that's only connected there. Then the output going to positive down here. Wait a minute. Are we not connected down there? We're not connected. Dun dun dun! That is a cold weld. A cold solder joint, rather, it's called. Yeah, it's the boring part of the circuit, but it's where you're going to find all the errors. I guess that was just sitting above it. No wonder weird stuff was going on. Okay, now that's connected. I forgot to solder that. Let's just make sure that that part is soldered too. There we go. Nice bulbous solder joints that'll ensure that we have continuity. So we weren't connecting it to anything, and I guess it must have been leaking and heating everything up, because now this is connected to here. You son of a bitch. There. I had to really stab it in order to get a connection. This is covered in flux. It's just oxidizing. Went on the internet and found these ohms for you. Thank you. Are they good ohms or bad ohms? Good ohms or bad omens? I can't do that joke properly, I guess. Okay, so you know, huzzah! Over here to over here. Ah, you son of a bitch! This thing is like, there you go. That's good. This one. This one's across the coil, positive to the coil. That's good. Diode this way. Diode this way. We're on ohms. It's not going to do that. I think everybody's good here. This one goes to D2. Oh, no, D3. No, which one shoots? Oh, no, it should be 1K. That's right. Yeah, 0.97. Wait, 0.98K? Huh? Is this shit 100K? No, it's 1K. Okay, it's going to a different pin. D2. Here. 0.9K. Wait, what's going on here? Something ain't right. Something ain't right. Oh, 0.989K. Oh, okay. All right, so that is 1K. All right, I got it. Everything is hooked up properly now. We didn't have our 100 volt connected properly to the output stuff. So now the pressure's really on. I think this might just work out of the box. I guess just for illustration's sake, I'll power it up as it is right now with no 100 volt connected, and I can activate the transistors to see if they get rowdy. So this will get up on the network. We got to give it some time. Once that light goes solid, then we're good to go. Oh, we're good to go. That was pretty quick. That was pretty quick. So I go over to my chat and I type colon, and then I hit AWW and I send the emote. And nothing gets hot because we're using these exactly how they should be used. Nobody gets hot. Okay. So now for the danger. I turn off the power supply and I go out to this camera so that we can get a nice wide view of everything either happening or not happening. This is frustrating because we had this thing 100% working. It's just that the power supply was permanently connected to everything, and I want to be able to disconnect it so that when I hit off the tip 122, it'll discharge those caps without all that noise getting over to this guy. This thing is made for like Nixie circuits, and I don't know how much protection it does or does not have. So now things get dangerous. Are we ready? We're going to try to observe heat. This thing just gets real hot. I don't know what's up with that. I guess it's okay, but all right, 3, 2, 1, power, go. It's not up on the network yet. We got to watch those transistors. If you want to do the honors, now's the time. Just one. Ooh, we got a little bit of charge out of it. Ah! Holy crap, that scared the shit out of me. And it smells like smoke in here. I'm turning it off, turning it off, turning it off. It smells like smoke in here. That scared the crap out of me. My hair is standing on end. Okay, so we actually got results. I mean, it charged to 25 volts, and then I think it blew up the transistors, though. We could try it again and see if it actually... Here, let's get the camera a little closer in, move this around. I can do like a table shot. And these scare me. So this over in the corner. Why is the white wire up like that? Wait, what's going on in there? Why is it up? I thought that was against the board. Huh. Must have moved it around so much that it's just dangling in the air. So concerningly, there was quite a bit of heat coming from over here, and I have silicon smell, the smell of burning stuff. So I'm going to turn this back on, and we will see the power supply heat up. We're going to take a look at heat right in here. So, hold on, I got to get my branding in here. My brand. Just haphazardly put that there. And then just in case it goes off, I guess I can... That'll just get punched into the wires. Let's just move this a little bit. Okay, so let's just see what happens here. So we're looking at heat, and we're looking at the voltage in the background. I'm going to kick this up a little bit. And then something might pop off. It might actually blow up because we've sort of stressed the silicon out enough. There we go. So I'm powering it back on. We are 80 milliamps at 12 volts. And so when the LED's on, oh dear God. So it gets hot and it smells like burning silicon, but it does seem to work. It just doesn't get up to full voltage. And of course we're charging for 4 seconds, so. See, look at that, it only gets that high. Okay, so we can stop this and try the next stage, which will probably blow something up. So the next stage is for, I guess, 1 second or 2 seconds. We will charge up with without the bypass activated, and then we'll activate the bypass. So this is where things get stupid. That worked though, right? That worked. It's just we didn't get up to full voltage. I was promised earth-shattering kaboom. Well, every now and then we do stuff right around here, and I do it as a joke, just to keep you guys on your toes. I'm working with 100 volts too. I don't think my poor little heart could take. I need to declare queue time. So queue time is going to equal 1,000, and this is going to be also 1,000. 1 Mississippi, 2 Mississippi. That might not get us to 100 volts, but it might also blow up the transistor. So I need to power this thing back on. I'm going to do it without the 100 volt supply in there. I'm going to pull that out so you guys don't get to blow it up yet. So plug this in, wait for the LED to come on. That'll tell me that I'm connected, and then we can try it again. I felt that electromagnetic wave from France. I can tell you right now, it feels like my increasing stress level. Okay, and then we're gonna upload. And that'll enable the pin that we're not using, and things will get nasty probably. I think maybe we're just overcurrenting these poor little transistors because they seem to get quite warm in operation, even though we should be well within spec. 125 milliamps is like nothing for this thing. This thing is rated for 600, right? It should be able to do 600 milliamps at 12 volts, but for some reason, it's not quite there when it comes to 100. It should be 160 volts, 600 milliamps. We're giving 100 volts at something like 125 milliamps. So we're well within the specifications of the thing. I think putting 10k ohm resistors is good in there. Ultimate Mall Ninja, there's a name I have not heard in a while. Ultimate Mall Ninja has subscribed for 5 months. Good to see you, bud. How's it going? All right, so we should have uploaded. Yeah, it looks like we have. Okay, so now I am going to connect 100 volts to this thing, which is harrowing and just nerve-wracking. So turn it off, let it dissipate the power. Then we're plugging this thing in. I didn't even know I had all these little transistors. These are good for like Nixie tubes and stuff. So I could run the what do you call it? I could run the VFD. Maybe not the VFD tube, but I could run the those no, they are VFDs, but they're VFD tubes that I have. I could use those transistors for that. Although I have a lot of those transistors, but I have way more tubes than I have things to run. All right, 3, 2, 1, power. Why did that get hot initially from power? It's like it activated for just a second. And then we've still got like 9 volts on the line. So when the Arduino turns on, it should fully do its stuff. Did you activate it? Did that go through? Oh boy, here it goes. Oh, where did the... Nothing... What? Well, it got hot, but then nothing happened. What the heck? Ah, Jesus Christ, scared the shit out of me. What the fuck was that? I don't want to get near this high voltage crap. That seems to be kicking off harder. Do it again. I smell burning. Yeah, it looks pretty spicy on the thermals. Although that's hot. That isn't necessarily burning, although it does. Why am I not seeing voltage build up? Oh, because maybe the transistors died? I think we finally killed them. Yeah, the Arduino's still lit up. I didn't do status LEDs. I really should have put some status LEDs on this thing so we could see the channel activating. Yeah, I think we're dead. Yep, that was no coincidence that I smelled burning. So, okay, I guess it's just the wrong transistor for the job. I don't know why. I do not know why. And our lines that are activating them aren't lighting up anymore, so that's a good thing. I don't know how much is in this capacitor. I really don't want to get a 100 volt shock. Let's move that off. So, this guy right here and this guy right here performed admirably. You guys did wonderful. I thank you for your contributions, but ultimately they gave in to the... Oh, it's the resistor. The resistor blew up. That is a blown up resistor if I ever done seed one. I don't think I have bigger resistors for this sort of thing. And our calculations said that it definitely shouldn't have blown up, but it did. Maybe the transistor survived and just the resistor blew up. Well, actually, let's test that. Let's test that theory. Do a little ohms across this thing. You guys can't see the screen, but I'm going to test it anyway. $30 kilo ohms. It's supposed to be 700, but it says 30. Maybe your math was wrong. It could be. We did a capacitor charging timing thing, and then my math was basically... What was it? It was a... 800 ohms with 100 volts going through. So at 800 you get about 125 milliamps. Like, it's V equals IR. It's not difficult. So I thought we'd be doing 125 milliamps, but maybe that's totally wrong. Because remember, these at time equals 0, these are essentially a short. So boiled down, our circuit is power in, resistor, ground. That's essentially what our circuit is. So it would be 800 ohms. And that would eventually charge things up down here. But V equals IR. So it's 100 volts, 800 ohms. So then it's, you know, simple math. So V over 800. So 100 over 800 is 1/8 of a watt. And it's an 0805 resistor. And it burned up. It burnt to shit. So maybe I need a bigger resistor. But it only charged to 25 volts. I got some thinking to do. I got some soul searching to do here. I'm going to save this diagram. This kind of works, but I think I need to come up with better stuff. The transistors heating up might not be that big of a deal. I think the burnt silicon smell that I was getting might have been from the resistor burning up. 750 ohms, that's a pretty meaty resistor. That should be able to survive this, but it might just be that there's some kind of like an inrush condition. And again, this is the inrush condition that we were trying to prevent. There apparently in the power supply, there is a massive capacitor. I'm not totally sure that there's a massive capacitor in the power supply. I'm just assuming that there's this huge capacitor that is connected right near where the 100 volt output is. And there's a big blue trace that runs right under it with kind of like a curved trace that runs like under this massive capacitor that may be what's hammering away at my components when it initially connects. Yeah, we made pretty good progress. I'm a little frustrated that we weren't able to get it like working. I would assume that this thing would be working and that things would maybe be out of spec by just a little bit. It did punch this pretty well. It's just the repeatability and burning up that one resistor. And believe me, that is a dead resistor. That is a dead resistor. It's not supposed to have no markings on it. Oh, that's cute. When I point like this, I point here, you can see me pointing from the other camera. This is over here. If I point like this, there we go. Now both fingers are pointing to the right thing. It's totally isometric. The resistors were played. It's a consumable. There's a little ping as it flips out of the circuit. I just have resistors that like fall in and then get like flicked away. Point left, the emote. Okay, so a little bit of progress on this. I still think this is viable. I think maybe if I size that resistor properly, we can get the timings down a little bit more. So we'll work on that next time. It is 5 o'clock here, so it's closing time for Bother. So I'm going to wrap it up. Yes, sacrifice for the stream. Every stream, I need to another thing on the list of things that I need to prepare for the next stream is put a resistor on in the emote thrower. Make sure my Twitch chat is up. Speaking of, is there somebody we can raid into? I'm not sure. All the big names are going. Carhole is going too. Carhole has like 20 people there. Paleontologizing is also going with 360 viewers. Other than that, I don't see too many avenues to go. I'm not streaming tomorrow. I'm working on my audio. I got to do it. I got to bring the mixer over here, and I got to sit down with the mixer, pair of headphones on, and I'm going to try to unmuddy my voice, and I'm going to try to get the compressor to work the way that I like it. So yeah, I'm going to need an intern to do all the setup ahead. My mids are too low. Don't. I'm gonna do it. I had people come in yesterday and comment on the stupid audio in here, and they this is not right, and this I can't hear you, and all that stuff. So what I'm gonna do is sit down with the mixer, and I'm gonna plug it in so that it's outputting from OBS, so I can listen to it immediately, and yeah, etc. Well, muddy, but you lower the certain frequencies in order to get rid of the muddy audio is what I was watching. But yeah, anyway, I will work on that tomorrow, and then on Saturday I might be back. We'll see. Sounds pretty good this time. I was one of the 2 people from yesterday. I need to sit down and with somebody's stream on, listen to it, and then something else, because too many opinions. Nobody's ever happy, so I just need to mix down for me, and then I can be confident that my stream is loud enough and that there's enough of my voice in there for it to sound good. So, but yeah, do a telephone filter. Yeah, there you go. RTX voice. We didn't use. I found a VST2 that is a neural network version of the RTX voice, and I was like really thinking about using it. And well, you know what? We're not using RTX voice because there's snapping noises. There's things going on in here that we need to be able to hear along with everything. So something's telling you that something's horrible, I'd be very skeptical. Listen, I got to do it for me. I haven't adjusted my audio in a long time, and I've got some conflicting information here that I'm going to address by doing my own adjustments and updating or getting rid of the M audio filters. So I'm going to get rid of the M audio filters and use just my mixer, and then I will forever know that my mixer can do exactly what I need it to do. It means updating the software on it, and it means sitting down with it and actually getting my lapel mic to work properly. Lapels are a little weird. They kind of pick up everything. And we have a preamp on the lapel, which makes it pick up everything equally. It doesn't do any kind of like sound manipulation at all, which is what I like, because I then get it into my workstation, and that's where I can edit everything. But in this case, with the stream setup, my workstation is going to be this mixer. I don't know if the mixer is going to lock me out of certain adjustments that I would really like to make. So I might go back to the M audio tools, update them, do the adjustments, and so it's a whole thing that I got to do tomorrow. And I will catch you guys maybe on Saturday, definitely on Tuesday. Here's the end card with the wrong date on it. Yeah, don't pay any attention to that. Just listen to what I'm saying. Your eyes and ears will deceive you. Believe what the party says. And the party says that the party is probably going to happen on Saturday, because I'll just be here with Willow on my own, and we can do some high voltage stuff, because that's always fun, / really, really frightening. Take care.